Okay, so let's start today's session with sed and awk. So hopefully you have the basic idea about what is sed and awk. So sed is a command that is useful for making mostly single line substitutions on a stream of text. So we can have some file or some std in our data, and we can then pass it through sed, and sed can do few operations like printing the line, dropping the line, and substituting the line, and also transliterating the lines. So let's create a dummy file to see that. So here I'll just add some lines here. So we have this file which has 3 lines of text, and each line has a lot of words in it. So there are multiple things that we can do with sed. So the simplest one is printing of a line. So if I simply give a file to the sed and we don't give any script to it, so usually the syntax of sed is sed and then the script or the actions to perform and then the file. If we don't give the file, then sed will expect the file to come from the standard input. And if we want, we can redirect standard input from some other file or output of some command. Otherwise, it will take from the keyboard. So in this, we have given the file. And because we have not given any command here, so the default behavior of sed is to print the lines as it is. So that is the default behavior of sed. We can also suppress that by using the -n. So if I use the -n, then the default behavior of printing each line will be suppressed. So this is useful if I want to only selectively print some line. For example, I can selectively print only the second line, and you can see the first and the third line are not printed, only the second line is printed. So similarly, we can also give a range of lines. So I can give 1, 2, that will print from the first till the second line. So 1, 2 does not mean 1 and 2. This means from 1 till 2. And we can also make it 1, 3. So all the 3 lines are printed. So this way we can ask sed to print it for a range of lines. We can also use negation. So for example, if I do 1, 2p, so you can see this prints the line 1 and line 2. So let me print the data so it's easier to see. So it's printing the line 1 and the line 2. But if I do 1, 2 exclamation mark p, so this is a negation of the address range. So this means for lines that are not line 1 and line 2, for those lines print, otherwise don't print. So this will only print the last line and not the first and second line. Instead of the line number, we can also use regex to search for something. So for example, here I can search for, let's say, the word EOS, and you can see only the last line has the word EOS, so that is printed. Whereas if I, let's say, search for something as simple as the letter E, then all the 3 lines have the letter E somewhere in them, so all the 3 lines are printed. And if I search for EOS, then only the last line is printed. So we can also use negation in here also. So if I use search for EOS, so the forward slashes mean regex. So anything between the forward slash is regex. And if I do exclamation P, that means any line that does not match this regex, print that line. So you can see instead of the last line, the first and second lines are printed. So we can negate address or a regex, and we can match address or regex, and we can also match address ranges, and we can also match regex ranges. So for example, let me first print the data. You can see the first line. So let me maybe add a few more lines, or let's say maybe let me create another file which is easier to see. So if I create something like this, you can see we have 26 letters. And let me make it 1 letter per line. And let me save this in a file called letters.txt. So if I now perform this sed operation on letters.txt, so if I search for, let's say, the letter G, then only the letter that is G will be printed and no other letter will be printed. Whereas if I, let's say, search for letter I and I do not print, then it will print all letters except the letter I. So here we can also, because this is regex, we can also do something like this. So I can do AEIOU, and this will only print those lines that have any vowel in them. And similarly, we can print lines that don't have vowel in them, either this way, or we can do it also this way. Both will give the same output. Here we are using regex to match anything that is not a vowel, and here we are using regex to match anything that is a vowel and not print that line. So any other line is printed. So we can also match ranges and do some action on the ranges. So for example, I can match the range from A till, let's say, G, and I can print those lines. So you can see only the lines A to G are printed and the other lines are not printed. Similarly, I can also inverse this. So only the lines from after G are printed and the lines from A to G are not printed. Just give me 1 minute. Okay. So we can match ranges, we can also inverse matches. So till now we have just been seeing one command, which is the P command, to print lines. And so that we don't print lines 2 times, we are using the -n. So what happens if we, instead of giving the -n, we don't give it? So each line by default will be printed once. And because we are also asking it to print a few lines, those lines will be printed again. So you can see any line after H will be printed 2 times. So each line is printed 2 times. And the lines before each, they are printed only once. So this is the default printing. And afterwards, it is default and then the printing that we have asked it to print. So instead of using -n, we can also, instead of printing, we can ask it to drop a line. So here what I'm asking is match those lines which are between the line that matches A and the line that matches G. And for all those lines, drop those lines. So here you can see only the lines after G are printed. So we can also have multiple commands inside one sed command. So here I can give a semicolon and give multiple commands. So for example, I can again give, let's say, J to L, and I can drop those also. You can see from H to J is there, HI, and then again J to L is dropped. And again, after L, all the letters are there. So we can give multiple commands this way. We can also give them in separate quotations. So I can give 2 separate quotations, but as soon as we give more than 1 quotation, we have to also explicitly mention that these are our scripts. So we have to use the -e flag, and after the -e flag, we need to have the scripts. And here we are mentioning 2 different scripts. One is to drop the lines that match A to G, and another is the script to drop lines that match J to L. So we can also make it bigger, maybe let's say till S. You can see all these are dropped. Right, so these are the printing and dropping. So there is
Sir,
yeah,
sir,
yeah,
I wanted to ask if drop also has negation.
yeah. So you can negate any action. So for example,
Okay.
let us see with just one, so it's simpler to understand. If I do one like A to G drop, then you can see only after H everything is printed. But here if I do negation, then you can see only A to G is shown. So here what I'm telling is any line that is not matching this, so which is not between A to G, drop those lines. And lines which are matching this, don't drop those lines. Right, so here we can see, because we're dropping other lines, we only get A to G. Right, so we can also combine multiple of these. So if I give, let's say, another one, here I give, let's say, K, so between K and S, and here if I give drop other lines, so you can see it is, oh
Do
sorry, I
we
forgot to
not
give 2 times.
need -e?
Yeah,
Yes, sir.
that's it. Yeah, so here you can see what is happening. So it is first seeing the lines that are not A to G, and it's dropping those lines. So we are left with only A to G. Then it's seeing those lines that are not K to S and also dropping those lines. So once we are done with the first one, we have only A to G, and the second one also drops those. So in the end, we don't have anything. So here, although it feels like we should have two ranges, A to G and K to S, this will actually have no output, because the way this works is it is deleting all lines that are not A to G first, so only A to G is left, and then it is deleting all lines that are not K to S. So the first A to G is being dropped out. So if you want to print multiple ranges, we cannot do it this way. We have to use the -n, and we have to use the P here instead. Now you will get A to G and this K to S. Right. So there's another thing that we can do in sed, which is called transliteration. So let me open the lorem file again. So here we have this data.txt. So we have 3 lines here, and assume that we want to make all the lowercase into uppercase and all the uppercase into lowercase. So one simple way is to use the tr command. So if I simply cat this out, so and I can pipe this into tr, and tr is a translating tool. So this is the only job that tr does. So I can ask it to translate anything that is from A to Z and from A to Z into A to Z and A to Z. So can anyone understand how this is working? So I'm giving 26 plus 26, 52, I believe, 52 characters in the first source range and 52 characters in the destination range, but the order is in reverse. So here I'm telling small a to Z and then capital A to Z, and the corresponding letters in the destination is capital A to Z, small a to Z. So it will make all the lowercase letters into uppercase and all the uppercase letters into lowercase. As you can see, the first letter was uppercase, it becomes lowercase, and the letters which are lowercase, they become uppercase. So this is a very useful tool. So if you want to do it directly without sed, also many translation tasks can directly be done with tr. So here you don't always need to give the entire characters. So for example, if you just want to translate some things, so we have always seen how to translate a single letter. So for example, let's say I want to translate all the F's into maybe X. So you can see all the F's have been translated into X. So if there were some other F also, I cannot find if there are, but they will also be translated into X. So here you can see also this F has been translated into X. But we can also do it for multiple characters. So we can make it for any characters. So one question which was given in the additional questions was creating a ROT 13 cipher. So ROT 13 is rotation 13, where every letter is moved 13 letters to its front along with like modulus. So A becomes N and N becomes A, etc. So with TR, this is very easy to do. You can simply say A to Z, A to Z, and the A should become N, right? So we go from N to Z, and then we go from A to M. So this A to Z is translated into N to Z and A to M. And then obviously the capital A also is translated similarly to N to Z and A to M. So you can see now this looks like gibberish, but this is basically translated into ROT 13. And one special feature of ROT 13 compared to other Caesar ciphers is that because 13 is half of 26, which is the number of alphabets we have, this is basically, what do you call it? Basically, if you run it again on the same data, it will give you back the same, the original data. So if I run the same algorithm on it again, N to Z, A to M, and N to Z, A to M, then we get back the original data. So we can do this with TR this way. So in TR, it's advantageous because we don't have to list out the characters. We can list out ranges of characters this way. So I don't have to write A, B, C, D, E, F, G, H all the way to Z. I can write A-Z. But if you want to do it in sed, then we have to actually list out the characters. So the command of doing this transliteration, which is done by TR, in sed is the Y command. So hopefully this last line is visible. So otherwise I can clear the screen. So this Y we write similar to the S or for substitution. So we write Y, and then we give a character that delimits where we start the source. So here, if I let's say give A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then my destination is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So if I do this on the file, which is data, you can see all the lowercase have been transformed into uppercase, and the uppercase have not been changed, because as you can see in our source, we only have lowercase. So we are only changing lowercases into uppercases, but we are not changing uppercases into anything. So if you want to do that, then we also have to basically type the same thing here. And we have to type lowercase here.
So, San, in this
Yeah.
method, we can do that cipher question, right?
Yeah, exactly.
Okay, got it.
Sir,
Yeah.
cannot we use S and G here to substitute the globally?
You can use SNG, but then you have to use basically 52 SNGs, right? So you have to substitute A with capital A, then we have to substitute B with capital B.
Cannot we use the regex here?
No, you cannot do a regex. You can do a regex by using the minus U. So here we are doing capitalization, right? So here you can do it with the minus U. So for example, you can do substitute any character which, one second. So substitute any character which is lowercase with the uppercase and that character, or you can directly use the ampersand. Yeah. So this will work because here we are making it uppercase, and we have to do a G here. Sorry. So this will work because we are making lowercase to uppercase, but in the question where we are making a ROT13 cipher, right? So there you cannot do it this way.
There
so,
cannot be used the range itself like N to M like that.
No. So you when you are substituting, the match can be a regex, but the what you are substituting with always has to be a string. So it cannot be a regex.
Okay.
Yeah. So
and
yeah.
One more thing, could you just explain this one alone using a file, like set file?
Which one?
Like we will give an input, right? Set file.
Yeah.
Yeah. Could you just explain, because I am getting confused while using that one?
Yeah, sure. So let's do the transliteration one. So this is what we were doing, right? So making all the lowercase into uppercase and making all the uppercase into lowercase. So if I directly give a file after this, then it will work on that file. But if I don't give a file, what I can do is I can cat out a file, and I can also pipe basically the same thing. So let me remove this file here. And at the start, I can cat out the file and pipe the output of the cat into the sed. So this will also work. So when sed is not given a file, it will automatically take from standard input. So in this first one, we are using a file, and in the second one, we are using a cat to pipe it to the standard in of this set. So if you simply want to give a file's content as standard input, we actually don't need a cat. You can directly do it with using the left angle bracket. So this will not give this as a file, but the contents of the file will be given as standard input to sed. So here also the output will be the same.
Right? So Sayan, the difference between the both is one, the file content will be changed and the other file content remains the same, right?
No. File content is never changed. So if you want to change a file content, you want to use the sed minus I.
Okay, got it.
So the difference between the first and the second and third is that sed is not aware of the file also. So even if it wants to change the file, it cannot. So for example, if I use the minus I flag, right? So minus I will basically change the file. So if let's say remove this. So if I actually give it the file and if I ask it to do it, so you can see there is no standard output to the screen. But if I now cat the file, you will see that file has itself been changed. So this will change the file itself. So if I do it again, then again it will undo it, obviously, because we are again toggling the case. But if I try to do that while giving it as standard input, then obviously sed does not know where the file exists. Sed is only getting it as standard input. So here you can see sed will give you an error that there is no input files. So you cannot change a file if you are not working on a file. So although we ourselves know that we are giving the value of a file to sed, but sed will not have this file. So sed does not know that we are giving this file. Sed only knows that it is getting this input from standard input. So that's why this -i does not work.
Sir, -i, could you explain again, sir? The previous command I'm able to understand. Sorry, the previous command said with the -i option. Could you explain again?
Yeah, so when you are using -i, instead of printing the change to the screen, it will change the file itself according to the change. So here we are making all the lowercase into uppercase, and we are making on the uppercase into lowercase, right? So if we do it without -i, it will read the file, make the changes in the memory and show the output, but the file will not be changed. But if I use -i, then the file itself, as you can see, is changed.
So basically -i is for inserting in the files itself, is it? Or any acronym?
So I is for in place, if I am not mistaken. Let me see. Yeah, I is for in place. So it makes the changes in place.
Permanently in the file itself, in the source itself.
Yeah. So it can only do it if we give it a file. If we give the data as standard input, then sed cannot obviously change standard input. So that's why it is only possible if we give it a file.
Sir, could you use -f and show this one once?
Yeah, sure. So we can also create a sed script. So let me create a script.sed. And here we can basically do the same thing. So we will say A, B, C, D, E, F, G, H, I, J, L, M, N, O, P, P, Z, this, and this. Let me just copy paste this. So we want to substitute this lowercase a to z and uppercase a to z into the uppercase a to z and lowercase a to z. So now let me actually open Pmouse. So now if I run this, so I can run it two ways. I can either run it as sed -f script.f and give the data.txt. So you can see it has toggled the case. Or I can also run this if I make it executable using the /script.sed. And here if I give the data.txt, you can see it is also doing the exact same thing.
Sir, what is this y slash?
So this y is the command that is used for transliteration. Just like S is for substitution, P is for printing, Y is for transliteration.
Sir, it's like character by character change, right?
Yeah. So every character in the source will be replaced with its corresponding character in the destination.
So length have to be same, right? One-to-one mapping.
Yes. It's a one-to-one.
Sir, can I use S instead of Y here?
If you are using S, then you will need 52 S commands, right? So you cannot do that. If you simply make this Y as S, then this will not work. So if you run this, you can see nothing has been changed. So you're trying to substitute a text which is ABCD. So there is no such text in this file, right? So what we want is we want to substitute A with A and we want to substitute B with B. So if you want to do that with S, you have to write 52 S commands. You have to write SA, capital A, then SB, capital B, SC, capital C, etc. So in these cases, Y is the better way to do this.
So, but in the command, we have not given SCD, right, sir?
No, because this is a sed file itself. So why will you need to write sed?
Okay. Yeah. Okay. It is not script.sh, it is script.scd1.
Yeah. So what is the extension of the file does not matter. I can have any extension. So I can make this script.sed into script.anything. So one thing in Linux you should understand is extension does not have any meaning. So this is just for your understanding. The system will never use this extension. So I can make this script.anything also. That does not matter. What matters is the shebang here tells that the executable is sed.
Oh, okay.
Yeah, so if the shebang tells this is a bash script, then this will run as a bash script. Yeah.
So can we use -f in the first line after f -n?
-n, yeah. So we can do that. Let me actually open this file again.
Yeah, okay.
So if I use -n here,
okay,
Then if I run this, you can see there is no output, right? Because the default output I have suppressed.
Okay,
So,
can we use like P like outside? Yeah.
No, so we cannot use P in Y.
Okay.
In like substitution in S, we can use P. So
Okay,
here
okay.
we cannot use P.
Yeah,
But yeah, we can do something like that. So for example, if I do 1P, it should print only the first line. Right. Similarly, we can do it for all of them. So the shortcut for all the lines is %. I can do %P. So this will print.
Dollar, right?
Oh, sorry, no,
Dollar.
dollar is the last line, right? So all the lines, I think it should be $1, $1, $P.
Sorry, $1,
Percentage is used in Vim and not in Z. I got confused for that.
And Sayan, one more doubt.
Yeah.
Regarding the shebang. So here for you, it's bin root bin. For us, it's, I mean, in VM, it's root user bin, right?
It actually depends. So here, if I see where is my sed, right? So you can see that sed is present in multiple locations. It's in bin sed also. It's user bin sed also. So ideally, what will happen is one will be a symlink of another. So if in some system this is not there at all, only this is there. In that case, this will not work. So then you have to do user bin sed. Yeah. So a better way of writing shebang. So this is kind of out of syllabus, but because you brought up the topic, I'll go over this quickly. A better way to write a shebang is, instead of giving the absolute part of the binary, we can use the /bin/env, and then we can write what is the environment that we want to run it from. So if I run this now, sorry, I don't think we can use the flags here anymore then. Okay, so /bin/env, and then we give the executables name. But for some reason, this is not working. So anyway, let us stick with this now. So in this case, in my system, user bin will also work and bin will also work. I think in VM also both are present. You can use both. Because I remember the solutions I made for.
But it will be better to just look into like type -s sed, and then whatever, I mean, here in this case /bin sed. So we can use this path in that shebang line, right?
Yes.
So it's better to first check this type -s sed, and then we can include it in shebang. That what you recommend?
Yes. So definitely, if you are, let's say, working on some system where you don't know, it is obviously better to first check.
I mean, let's say the VM itself will be giving a quiz. So probably, yeah. Okay, thanks.
Yeah, to be like to double check, you can always run this just to confirm that it is actually present there.
Sure. Thanks.
It's a type command to check, is it, sir?
Yeah, sorry.
Is it a type command to check like what version of sed is?
It is not a command. So if you see type is a shell built-in. So it is not a command. It is something that is present in the shell itself. So this is similar to a command, but not a command. So this will tell you whether something is a command, or it is a shell built-in, or it is a shell keyword, or if it's a command, then where it is present, everything it will tell. So for example, if I do type the square bracket, it will tell, so it is present as multiple things. It is present as a shell built-in, but it is also present as a binary in all these places. Whereas if we see the double square brackets, which is a part of bash language syntax itself, so there you can see this is a shell keyword. So this command is, I mean, this shell built-in is useful to check what kind of thing we are running, whether it's a keyword built-in, or if it's an executable, then what is the path of the executable.
So here, if you say keyword, sorry, please go on.
No, go ahead.
Okay, so what I'm asking is, when you say built-in, I can understand shell is a built-in, sed is a built-in, awk is a built-in, right? It's a
no. Sed and awk won't be built-ins usually. So you can see sed is always executable present in a path. Only very frequently used and very simple commands are built-in into some shells. So in bash, some things are built-in, like the square brackets, because it is very often used and because it's very simple command. So we have a built-in version of it in the shell itself. So it does not have to go into the file system and index the executable. Directly in the shell, it has the instructions of how to run something like this. but most things will not be a built-in.
Yeah, I wanted to add which also works, right?
Yeah. So which will only tell you the paths of executable. So if I do which, it will only tell you that this is present in sbin. So what which does is, which will tell you which path of this will be executed if I run this from the terminal. Whereas with
So I can
type
use that
minus
for
a,
shebang.
yeah. But for type minus, it will list out all the places. So this one will be there, but then all the others one are also there. And if it's a shell built in, then it will mention that also.
Okay.
Yeah. So if you do which sed, it will tell you /sbin sed. So you can use /sbin sed also in your shebang. You can use /bin sed also. So it depends on your VM. So if in your VM this sbin is not there, then this will obviously not work.
So we can check in our command prompt and use the respective one in our set program.
Yeah, exactly.
Okay.
Sir, we can use sed and awk in bash, right?
Yeah, you can use sed and awk in bash, but if the question itself asks you to write a sed script, right? So script.sed or script.awk. So in that case, you cannot write a bash script, right? So you have to write a sed script like this. So the file name also in that case has to be script.sed, but ideally it can be anything.
Yeah.
But the script has to be like this. It has to be a sed script. So you cannot write sed here. So it is not a bash script. So you have to basically give this shebang, and it has to be a sed script.
Okay. Just
so what is between like putting a Y in the front and like P in the back, right? Is there any difference or?
Sorry, can you repeat that?
So like in some of the command we put the like a Y in the first, right? But like for P and the other command we put at the last, like after the last slash.
Okay. No. So it is always after the address. So this may look like it is before, but it is always after the address. So here, because I have not given anything, that's why this is simply here. So what this not giving anything by default means is $1, So this and this is exactly the same. So I'm telling for all the lines, perform this following command. After this is the additional thing that Y requires. So similarly for sed also, sed will require some things like, so substitute what to what. But for some commands like print and delete, they don't require any additional information. Just telling to print means it will print, and telling to delete means it will delete. So always the first part will be the address range. If you don't give the address path, then that means it is for all the lines. So here also I can drop this basically, and this means do it for all the lines. And if I give a particular address range, then it will be only for that line.
So can I put P in front of like Y? Would that work, or it has to be at the end or something? Some command has to be end, some has to be at the start.
So each command has to be on its own line. And here, each command has to be in this following pattern. So it will be first the address range, and then it will be the command. So some commands will have some additional information required, like Y and S requires you to transliterate what to what, or substitute what with what. Whereas some commands P and D, they don't need any additional information. So you may or may not have this options of those commands. But the address range is always the first thing, and command is always the second thing. If you don't give the address range, that defaults to printing, like doing that command for all the lines.
Okay, got it.
So using this, we can actually, in Python course, we learned about that cipher, right? A is encoded as a D, B is encoded as a E, right? So you're shifting the bit by 3. So it can be very easily done with this transliteration.
Yeah. So the similar thing we gave as the additional questions, right? So that what you're telling is, I think, ROT 3. So the one we have given is ROT 13. So basically move everything 13 characters forward. Yeah. So that is the Y, how we can use the Y. So let us see also how we can use the S for substitution. So right now, the file we have is...
one more doubt I had about the Y one. If we have more characters on the left of the power slash, on the left side, if we have more characters and on the right we have fewer characters, would that cause some difference?
Let's see. So you're telling we have less here and more here, or more here and less here. So let's test both of them. So if you do that, you will get an error that the strings are of different length. So both of them has to be exactly same length, because it's a one-to-one mapping, right? So every character we are mapping to that index character on the right side. So both of them has to be the same length.
And can we use the square brackets and the expansion you did for the TR command?
No, so in this you cannot use. So for example, if I try to do that, change till A, if I make it A to Z, so I don't think this will work. Yeah, so you can see these are taken as literal characters. So this is taken as a literal square bracket, and then this is taken as a literal minus sign. So it's still complaining that they are of different lengths.
So backslashing won't work.
Let's try that also. And let's try backslashing maybe this one also. Right, so you cannot use regex in this one. So for the Y, which is transliteration, it only has to be characters. So list of characters.
Okay, got
it.
Yeah. What is this question? I'm not able to follow, sir.
Sorry?
What is this question? I mean.
So we can do the same thing in TR by giving the character ranges, right? So I was asking if we can give character ranges in sed also in the Y. So in the Y command, we cannot give ranges, but in TR, we can give ranges. We can give ranges in sed if we are using the substitution. So let us see the substitution also. So let me first print the file itself. And here, let's say substitute some word with some other word. So for example, let us substitute this word with some other word. So hello. So if I do this substitution, what this means is substitute this occurrence of this word with this word in each line. So if I run this, you can see this has been substituted with hello. But by default, the S command will only substitute once per line. So if we have 3 occurrences on each line, only the first occurrence of all the lines will be substituted, and the others will not be substituted. So let us see that with another file where it's easier to see.
So that's where we use global, is it?
Right?
If I want to change only the second occurrence, I'll do /2.
Yes,
right?
yes, exactly.
/2 near S, sir?
No, the last one. We'll go into that.
Sir, what is this minus F option? Like minus N is for suppressing the default behavior. So minus F is like taking the input from the file or something?
Yes, yes. Same as grep. So we are giving the script from a file. So this is the file.
Okay.
Right. So here, let me.
It will not take from the standard input.
No. It will take from the file on which it is working on. It will take either if it is given as an argument, it will take that. If not, it will take from standard input. But the file where the pattern is defined, that will be this file which we are running. Right. So here, if I run this script.anything and I give it demo.txt, so let me change this and let me substitute hello with, let's say, the capital hello. And if I do this on this, you can see the first hello is made into capital, whereas the second hello of this line is not made into capital. So the first hello of this one is also made into capital, but this one is not made into capital. Same in this line. So the first hello, so there is only one hello, so it's made into capital. Whereas the second one is not made, so there is no second one. But in the second line, the second one is not made into capital. So if I want to, by default, this will only substitute the first occurrence of each line. So giving a 1 and not giving a 1 is exactly the same thing. So this will also give the same output. But if I want to, let's say, substitute all the second occurrences of each lines, then we can give a 2 there, and then the first occurrences will not be changed. So you can see the first occurrence remains as it is. And only in this line, because we have 2 occurrences, the second occurrence gets changed. So the change can be anything. It does not even have to be the same length or the same words. The change can be anything. And in the sed substitution, we can use regex in the search part. So it doesn't even have to be a string that we are searching. I can say HEL and then 0 or more else and then O. So this will also match hello. So you can see it will substitute the second hello to word. And if I want to do it for all the occurrences of a line, then I can put a G here. So giving a G means it will do it globally for each line. So here you can see all the hellos have been substituted into word.
So that P is on the next line, is it?
This is a different command.
I can't bring that P to the before line.
Yes, you can. So for S, you can give a P after the last
G.
slash. Yeah, so you can give it
Got
like
it.
this.
Okay.
So this will also print.
So here 2P will not mean print the second line.
Sorry.
Instead of G, if I am giving 2.
Yeah.
Will
So
it make
this
it
means
second occurrence or second
occurrence. Yeah. Second occurrence. Okay. So let me ask you this: what is the difference between putting a P here and putting the P in the next line?
After substitution, P is applied.
Yeah, but like in the output, what will be the difference? So if I have it like this, this is the output. It's okay. Let me maybe add another line here.
The P separates exclusively on all the lines.
Okay. And what happens if I do this?
Only the substituted lines will be printed.
Yes, exactly. So here you can see the last line is not printed, right? So how are you? It does not has the hello. So if the substitution is unsuccessful, then it will not print. Whereas if I give P as a independent command, it will obviously print for all the lines. So in the first case, all the lines are printed after the substitution. Whereas in the second case, only when substitution is successful, the lines are printed.
Okay, sir, one doubt. If you want to substitute till the second, like 2 hellos are there, substitute, else don't substitute. How to do?
Okay, so you want to substitute if, like, let's say there are 10 hellos in a line, you want to only substitute the first 2 of them, is it?
Yeah, first 2 occurrence. Like
okay. So let's try that. Let me add a few more hellos here. Okay, so we have these many hellos. So right now we are doing it for all the ones. So instead, if I do it for only the first one, so this will only do for the first one, and I forgot to print it. So now it is doing only for the first one. So the first hello becomes word. And if you want to do for the first 2, I think this should work. Let me check. Yeah, so you can see the first command first substitutes the first word, first hello into word. And then the second command substitutes the next time the first hello into word. So obviously after the first hello has been made into word, the first hello for the next command is the second hello. So that also becomes word. So in this, if you have only one, then only one will be substituted. If you have more than 2, then only the first 2 are substituted.
Okay, so commands have been executed simultaneously, right?
Yeah, one after the other.
Okay, okay.
So more like pipe command, is it?
Yeah.
Yeah, you can think of it that way. So the what happens is for inside every line, so it works line by line. So every line will first be brought into the pattern space, so a place called the pattern space in the memory, and then each of these commands one by one will be executed on the pattern space. So
okay,
this
like
is executed.
It will be using, right?
Yeah, so it will run this first command on the pattern space. So the pattern space got changed, right? So substitution was done. Then this will again be run on that same pattern space. Yeah.
Can we put a range also? Like if I want to change all the first, third word, then
first and third. Yeah, you can do that.
No,
so
1 to third 3 words. Like in line 2, if I want to change first 4 hellos, then how can we do that?
Okay,
like,
so if
is
you
it
want
necessary to write it again and again, or we can just put the range?
I don't think you can put a range here. So you might be able to do it with branching. So we'll come to branching in a few minutes. So otherwise, yeah, you cannot give a number directly here. So for example, if I give, let's say 1,4, then you can see this is not a valid option. Or if I give, let's say 1-4, then that is also not a valid option. So we cannot give ranges this way. We might be able to do it with branches. So let us take this question up again when we are doing branches on set.
Okay.
Yeah. So if you want to do like just the first 2 or something like that, you can do it this way. So if you're doing it, basically what happens is the pattern space is substituted once, then the pattern space is substituted again, and P simply means whatever is there in the pattern space, print that out. So this way you can do substitution. And here, because this is a regex, you can match anything you want. So we don't just need to match a single string. We can match any other kind of pattern. So for example, I can say anything that starts with H and then has any character A to Z present, let's say 2 times or more, or let's say 3 times or more. So to do that, because this is a basic regex, we have to escape the curly brackets. And if I substitute that with word, and let me do it for all the occurrences. So then you can see all of the hellos have been substituted, but the house have not been substituted here. So why is that the case?
Because 3 and more, right? After H.
Yeah.
OW
yeah,
and
yeah, exactly. So
if you make
H,
it 2, maybe.
Yeah. H itself is 1 letter, and then we are asking 3 letters after that. So if we make it 2 letters, then it will substitute the how also with word. Yeah, exactly.
Yes, and I wanted to ask you if I could skip the first occurrence and I could go to the second and third occurrence alone. Like,
yeah, obviously you
so
can also do that. So like how we were doing earlier, right? So here, if you instead of 1 1, if you make it 2 2, this will substitute the second and the third occurrence, right? So you can see the first one remains as it is.
Second and fourth, right? Okay, second and third.
Second and third, because once
okay,
like
again one will be there. Okay,
yeah,
got it.
One will always be there, and then first this is the second, and then after we change it, then this is the second.
So then odd occurrence, if we want to do, we have to write till odd, every odd numbers.
Yeah, if you want to do it in odd occurrence, then you might. So it will usually be easier to do it with either awk or like using a bash script. So you can also maybe do it in sed if you are using branching. So we'll have to look into that. Okay. But in that, like then it becomes like kind of an esoteric way of doing it. So it will be way easier to do it if you're doing it with awk or with bash.
Okay, and here we cannot negate like first occurrence alone like that. If you
no, so you cannot do a negation on the like argument of the command. You can do a negation on the like before in the address space. So for example, we can also do substitution by matching like a pattern. So for example, we saw that we have hello in all these first 3 lines, but if I ask to do it only in the second line, then this will only do it in the second line. So you can see the first line and the third line is unchanged. Only the second line's first occurrence is changed. And I can also do a negation here. So I can do except the second line. So now the first line gets changed, the third line gets changed, and the second line is not touched at all. So we can do negation in the pattern space here.
Only lines alone we can do negation, not the replacement.
Yes, that's good. So here we can also give something to search. So for example, I can say only if there is a how are you in the line, only then do substitute hello with word. Right. So you can see if we run this. So this one which has how are you, the hello becomes word. Here also we have how are you, so this hello becomes word. Whereas this line which only has hello, that is not changed. So we can also perform a search and we can do the substitution. And similarly, we can also negate this as well. Only this line gets changed, the first occurrence, and the other ones is unchanged.
Sir, if I do like semicolon instead of negation, will it work like simultaneously?
Semicolon instead of?
Negation symbol.
Okay, so if you do semicolon instead of negation symbol, then it will basically give you an error because you're asking to search. Yeah, you have to give some command here.
Yeah, P if you give, it will be printing.
Yeah, then it will be printing for those lines, and then it will substitute for all the lines. And because we have given print again, so it will again print. So lines that are matching this will be printed 2 times. So you can see how are you lines are printed 2 times. Once before substitution and once after the substitution. Okay. And the lines that don't have how are you, they are only printed once after the substitution.
Okay. I tried this one for this ending question. That's fine.
Yeah.
I could just take that P to the top, right? So that I could,
if you take the P to the top, then both the printings will be before the substitution. Right. So here then
not there. I meant near one.
Sorry?
Near 1.
This one?
I was saying like this P to near 1 afterward.
Okay. Yeah. You can do that. But then here, if you don't have anything, this is an invalid command, right? So you're searching for
not
something.
This P. I was saying regarding the P below it.
Okay, so we saw that already, right? So if you don't have the P here and you have the P here, then it will only
you won't get it repeated, right?
No, it will still be repeated, right? So because we are printing 2 times. So you can see we are printing once for lines that are matching. How are you? So this is printing hello, how are you? Then it is substituting and printing. So it is printing word how are you? Yeah. So all the lines where substitution is happening, it is printing, and all the lines where how are you is there, it is printing. But if there is a line where how are you is also not there and hello is also not there, then it will not print that at all. So for example, if I have another line here, that will not be printed because both these are conditional printing, right? So here we are printing only if this regex is matching, and here we are printing only if this substitution is successful. So because this is not satisfying either of this condition, this will not be printed at all. And where lines satisfy both these conditions, they will be printed 2 times. Once before the substitution, one after the substitution. And hopefully this makes sense.
And one small doubt is about the execution of these scripts. If we just source them, we do not need to like change the execution status, right? We do not need to give permissions.
If you source the set script, you cannot source a set script, right? So source is a way of running a bash script inside bash without creating a subshell. You can only source a bash script and not a set script or an op script.
So in case of bash scripts, if we source, we do not need to give execution permissions, right?
Yeah, that is also not the correct way of doing it. So sourcing is for a different reason. So if you source, then it is basically run in the same shell. So any variable declared in the script that will be available even after the script is stopped. So if you want to run some script without giving it the permission, you should run it this way. So bash and then script.sed. So similarly, if you are running a sed script and you don't want to give it a permission, you should run it like sed -f script.sed. So here we have not given anything. So if I give hello, you can see it becomes word. So here you can also give a file, like here I've given demo.txt.
What does the -n would do? Like when we pass n?
This -n means it will suppress the default output. So here if we run it, so you can see the line which is 1, 2, 3, 4, that is not being printed, right? So it is not printing any line by default. Only when we are asking it to print with a p command, it's printing. So here we have 2 cases where we are asking it to print: when the regex of how are you is matching, and when this substitution is successful. So that is basically when a hello is present.
Okay. So if we remove one, it will print the input and then the output.
Yes. So then it will print a maximum of 3 times, because 1 is the default printing, and then 1 is the printing which is happening if it is matching how are you, and then this third printing will be printing of this sed if it is successfully substituting.
That would print at the last, right?
Yes. Okay. So this default printing will print at the last. So this first one is printing before substitution. This one is printing if substitution is successful, and then this is the default printing. Similarly, here you can see the how are you was not matched, so it's not printed, but the substitution printing is there and the default printing is there.
Cool.
And in the last line, none of the conditions are matching, but the default printing is printing it once.
Okay.
Yeah. So another thing you can see that if we are running it this way, sed -f script dot anything, so then this line is not read, right? Because I'm not running it from bash as directly a script. I'm giving this file to sed. So then this shebang has no value to sed. So then you can see, even if we, let's say, have an n here. So you can see if we have an n here, then this 1, 2, 3, 4 is not being printed. But the same file, if I run it this way with sed, then you can see this 1, 2, 3, 4 is being printed. So if I'm giving a script file to sed, then this is simply because it starts with a pound sign, right? So this is simply a comment. So this is ignored. So even if you're writing -n and -e, all that, it will only work if it is run like /script.sed or script.anything. If you're running it this way, sed -f, so then it is just reading the script line by line. So it is ignoring the comment, the first line. So then it is still printing here. So if you want to have -n, if you're running this way, then you can put the -n directly in the command. And hopefully this makes sense.
Okay.
Yeah.
If I want, like, when we have to find the range of lines, like second line to fifth line, we can do normally 2,5p, right?
Yes.
So here, since you are doing how are you and /p, suppose I want the line that has hello, how are you, and then hello, how are you. So here also, can we do it by using comma and then another slash and the line?
So print all the lines between these two lines, right?
Yeah.
Yeah, you can do that. So for example, same way as you do with line. So you give the first thing, you give a comma, and then you give this one. So this is hello, how are you? So if you do this, then all the lines, including these lines and the line between them, will be printed. So if I run this, you can see that this one. Okay, why is it printing everything else? So hello, how are you is being printed, and the line between them is printed, and how hello are you is printed. It should not print the last two lines. Let's see.
So the first regex will have hello, how are you? It only has how are you?
No, but regex is regex, right? So it can match any part of a string. So that
then
is
you'll
not
match the second last line and then still print the last line.
Yeah. That is what is happening. So it's this how are you is matching this how are you also, right? So it is trying to go till the end, but it is not finding the end part of this, but it is matching the first part. So here, if we actually restrict this by making this hello, how are you, then I think this should work. Yeah, right. So here this how are you was matching this one and also this one. So it was starting another group here. So if we give it correctly this time, then you can see that it is matching only till here. So it's only printing the starting, ending, and the lines between them.
Could you explain what does it do? I'm not able to understand.
Yeah, so just like we can give 1,3p to print lines 1, 2, 3, I can also, instead of giving 1 and 3 as line numbers, I can give regex. So anywhere this regex is matched is where the starts, and then anywhere this regex is matched is where it ends. So any line, including those lines, and any line between those lines, they are printed. And because we have n, other lines are not printed. So here, hello, how are you is matched in this first line, and hello, how are you is matched in this third line. So first line, second line, and third line are printed.
Oh, God. It looks, because it was line break, right? I thought it was like 4 lines.
Okay, no, this is one line itself.
So cannot we use hyphen n in line number 1?
Sorry?
Hyphen n in line number 1?
No, we cannot use a hyphen n directly in the command itself. So if you do that, you will get an error.
Not here, like hyphen f we will use to run, right? In that.
Yeah, here, right?
No, not in the script we will run, right? In like sed.
Okay, yeah, if you're running it like that, then you can do that. So you can do sed -nf.
No. Here, if we use n, we cannot use. Here, we have to use hyphen f, and in pattern, we will use hyphen n. Like that, can we use?
So can you tell what you want me to
Yeah. In the script dot anything is there, right? There you have to give the first line as hyphen n.
Okay. You want me to remove this f?
No. The second line, next line after the shebang, hyphen n.
Yeah.
This is, and save this one, and and we have to trigger the script using set hyphen f. And
like this?
Yeah, I like this. So will it be taking like script or anything as text, or how it will be working? I want to just clear.
No. So it will, because whatever you give in the script, it has to be a sed command. So these are flags to the sed executable itself. So these are not sed commands. So whatever you put inside the single quotations, right? So that is the sed command or the sed script. So you can only put sed scripts here and not flags. So
okay, so if you want to negate, like suppress the default output, how will you do here?
So if you are running it as like this, if you're running it with sed, you can directly put the n here. So you can do -nf script.anything demo.text.
But we cannot edit the files, right? Script.sh files, right?
Yeah. So if you are unable to change this, so if it is being run this way, like /script, then you can have this in here. But if you are unable to change it and it is being run this way, then you have no way of basically suppressing the default input.
Okay.
Then you have to use basically D to drop the lines you don't want. Okay, so for example, here, let's say I don't want the line 1, 2, 3, 4. I can simply do search for 1, 2, 3, 4 and drop that line. So even if I run it with sed -f script anything, then the -n is not working. So we are getting things printed 2 times. But you can see the 1, 2, 3, 4 is being dropped. So it's not being printed. So similarly, you can also do it for all the lines. So you can say D simply. So no lines will be printed. So only the ones that you are printing will be printed. If you are unable to add -n anywhere, you can simply give D. So D means drop. And if you don't give any line number, it will drop all the lines.
Okay. Simply D will work. Okay, fine.
Yeah.
In the second command, which you use to change the word hello with some other word, can we do it? Can we change 2 words by using pipe with just 1 word? Let's, for example, let's say I want to change.
Okay. Yeah.
Some.
Yes, you can change both the words of hello and R. Actually, you don't even need the down bracket. So you have to escape the pipe because this is basic regex. So you can substitute both of these to let's say some other word might happen. So if you do this and I run this on the demo.txt, and I have to also print those lines. Sorry. So then you can see both hello is also changed to Apple and R is also changed to Apple.
So what should I escape? We saw that you are not escaping the square brackets. So
right. So as we already discussed this, there are 7 symbols that have to be escaped in BRE, but not in ERE. So just keep, so this is basically the info page. So info sed, here you can find the regular expression. Here you can have BRE versus ERE. So just go through this page. So here it explains what are the differences between BRE and ERE. So there are these 7 symbols, question mark, plus, round and curly brackets, and the pipe symbol. So these symbols, if you want to use the special meaning, either you have to use ERE or in BRE, you have to escape them. So if you want the special meaning, you have to escape them in BRE or you have to have it normally in ERE. Whereas if you want the literal meaning of those symbols, you have to have it normally in BRE or you have to escape them in ERE. The square bracket always has a special meaning both in BRE and ERE, so you don't escape those. If you want to literally find a square bracket, then you will have to escape those in both BRE and ERE.
Okay.
Yeah. Sorry. So yeah, this way you can obviously, because this is also regex, right? So any regex you can do in grep. So your week 4 understanding of regex will carry on into week 6 and week 7 also. So in sed and awk, the regex will be exactly the same. So in sed, by default, it will be basic regex. In awk, by default, it will be extended regex. But in sed also, you can change it into extended regex by adding a capital E or lowercase r here. So what this will do is it will use extended regex. So in that case, you can not escape this. You can see this is still working. But obviously, if you are running this as like sed minus, let's say NF also, but if you're giving it this way, then obviously this first line will simply be a comment. Then the E will not work, right? So you can see then we are not doing any substitution. So make sure that if your script is always being run this way, then you are fine giving the arguments here. Otherwise, to be safe, simply use the BRE and not use capital E here. So anything you can do in BRE, you can do in anything you can do in ERE, you can do in BRE also. You just have to escape a few symbols. Right, so you can like this, you can find like replace multiple things. You can also replace some patterns. So for example, let me create another file. And here, let me add a few words. And one of those words will be, let's say, a palindrome. Or let's say 2 of them are palindromes. So in this, what we can do is we can replace, let's say, 5-letter palindromes into something else and 7-letter palindromes into something else. So how we can do is the same as grep. So how we match palindromes is exactly the same. So here also we will basically, so let me make it either gaps. So we will basically match groups of letters. So the first group, the second group, third group, and then if it is the second group and then the first group. So this is how, sorry, not / second group and then the first group. So this is basically a 5-letter palindrome. So then we replace that with, let's say, the word 5-letter palindrome. So if I run this on this word, so you can see, why is this? Okay, yeah, actually, here also we have a 5-letter palindrome, right? So A and A and A, that is also a 5-letter palindrome. So we get B 5-letter palindrome. And similarly, in race car, so although the entire word is a 7-letter palindrome, inside that we have a 5-letter palindrome also. So ace car. So that has been changed. So it is R 5-letter palindrome R. So to prevent that, how can you do that? How can you make sure that only words, like entire words are
symbol we have to use?
Yeah, you can give a \p. Yeah, so word boundary you can search. So now only a word which is exactly 5 letters and is of this pattern, right? So 1 character, 2 character, 3 character, then same as the second character, and then same as the first character. So 5-letter palindromes we are replacing with something like this. So similarly, we can do it also for 7-letter palindromes. But if you want to basically find palindromes of any length, then ideally it will be better to use something like a bash or an awk script. So how can we do that? So let's see this in bash first. So we have this words file. So if I do, so let me use that. So I can see these are the lines. And if I now use the rev command, so rev is a command that will reverse each line by line. So it reverses each line this way. And you can see only the palindromes, obviously, even after reverse, they will look exactly the same. So one way to do this is we can use a while loop. So I can read each line one by one. And for each line, what I can do is I can say that if the line is same as the reverse of the line, I can say that if the line equals, and then I have to run reverse on the line. So if I run reverse on the line and the output of the reverse on line is same as the line itself, then I echo that line. Otherwise, I don't echo that line. So here you can see out of all these words in the words file, we are only printing race car and madam. So it doesn't matter how many length it is, it will work for any arbitrary length, because here we are not matching letter by letter. We are simply reversing the entire line and checking if the reverse of the entire line is same as the line itself, and then we are printing that line. Right, so hopefully this one is clear how we are doing this. So instead of that, what we can do is we can directly use the left bracket. So here we can do left angle bracket words. Right, so just let me know if this was clear, how we are matching palindromes.
So what is the triple less than line mean?
Yeah, so yeah. So we covered this in the previous revision session. So if we have a single less than, that means take the file, which is this one, and feed its lines one by one as standard input to whatever is before that. So here we are taking one line at a time from words and giving it to this while loop. Whereas triple less than means take this string that I am giving. So instead of, so here it is name of a file or path of a file. And here it will be any string. So here I have given a variable, but this can be even a fixed string also. So take any string and give that as a standard input to the command that I have on the left. So this is for giving files as standard input, and this is for giving strings as standard input. So here, because I'm iterating over each line one by one, and I have the line saved in the variable line, so I can directly give that variable to ref. So this is exactly equivalent to doing the following thing. So instead of this, I can do echo line pipe ref. So both of these are equivalent, but here we are using one command and piping its output to another command, whereas this is directly done by bash. So this will be a few microseconds faster than this. And hopefully this is clear.
Yeah, got it, sir.
Yeah. All right. So similarly, in sed, we can basically match any kind of regex. So you can also use back references here. And another thing we can do in sed replacement is, obviously we saw we can use the ampersand to get whatever was searched. So for example, if I run this again, nothing changes because I'm substituting what I found with exactly the same thing again. But I can also put 2 ampersands. So what it will do is it will duplicate the 5-letter palindrome. So you can see madam becomes madam, madam. And another thing which we can do is we can use something like the backslash lowercase u, backslash uppercase u, backslash lowercase l, and backslash uppercase l. So what these do is they will make whatever comes after it uppercase or lowercase. So in this case, you can see the original data is lowercase, but if I do backslash u and ampersand, so ampersand basically means exactly what was matched, so the entire madam, but now it becomes uppercase. Whereas if I have lowercase u, that means only one letter will be uppercase. So it will only have the first letter of madam uppercase and everything else will be lowercase. Similarly, if the data itself was uppercase, then we can use lowercase l to make the first letter lowercase and uppercase L to make the entire data lowercase. So this is also useful if you want to search for some word and make it uppercase. Right. So now let me ask you one thing. So let's say I have, let's say I have one line with a lot of words. And in this, what I want to do is I want to basically make all the words first letter uppercase. So I want to make it a word case. So this is already uppercase. I want this to be uppercase. I want this R to be uppercase. Everything else should be lowercase, but the first letter of each word to be uppercase. So how can I do that in sed?
So I have to basically.
Okay, so the what is the command that we're using? S, right? Substitution.
S.
Okay, then.
And then I'll do a group.
Okay.
For one dot, that is one character.
Okay.
And then I'll follow it. Close the group, and then I'll follow it by dot star. So that will make a word for me.
Okay.
Now I'll back reference using 1 and make it uppercase.
So now we are ending the search and going into the replace, right?
Yeah.
Okay. Yeah. So we are doing uppercase or \1 and then
search. And I'm gonna print it.
Okay. So like this.
It should work, I guess.
So this will
okay,
not work.
Invalid reference.
Okay, why is it telling invalid reference? Oh, because we are using extended edits. I should not have escaped this. No, so it will not give you an error, but it will not work. So what it will do is it will only print one letter. Because you're matching only one letter in the group, right? So you're printing only that one letter.
Yeah.
Okay, so what can you do?
You can search for alpha, word break,
okay.
Then alpha, then word break.
Okay, so word break, then A to Z, and then
word break.
Yeah.
And then you
Do we need to add star because it can occur multiple times or just once again?
So I'm asking you. So I'll tell you the solution, but then I want you guys to try to solve this.
Oh yeah, there will be star also because it's
so
multiple words, right?
Yeah. So multiple characters, and then
this is it, and then you and
then and. Okay. Okay. So let's see. Okay. So this might be working. So let us try with G, right? So because otherwise it will only do for one occurrence.
First one.
So yeah, so here you can see this is working. So here each word is being matched. So what we are matching is word boundary, and then any alpha character, lowercase or uppercase, present 0 or more times, and that we are replacing with making the first letter uppercase and the entire thing that we search for. So yes, this will work. So although there can be a easier way to do this.
Sir,
Sam,
if you want to accept only the first letter lower and rest of the upper, how will you do?
So in that case, sorry for the disturbance. There's a procession going on. I think then you have to first make everything uppercase and then make the first letter lowercase. You cannot do it directly. You may have to do it in 2 commands. So, but let's try to do this itself in a less number of characters. If I search for anything that is A to Z at a word boundary, and I can simply uppercase that. So this should also work. Right. So I don't actually have to match the entire word. I just need to match the first letter of the word. So word boundary means I'm always matching the first letter of the word. And actually, I don't even need to match uppercase words, because if it's uppercase letter as the first letter, me substituting that with its uppercase value will make no change at all. So if I simply search for all the lowercase words, letters, that is the first letter of the word, and make it uppercase, then itself it will do the same thing.
So a small u will make the first letter of a word caps, and will the how
here-
will I make the entire word? Yeah.
Yeah, so if you
Entire
want to
word
make the entire word uppercase, then you have to basically match the word. So here, because I want to make only the first letter uppercase, so I have used small u. Here, capital U will also work because my match itself is one letter. So it doesn't matter whether I use small u or capital U, because here this is just one letter. If I had matched the entire word, then sorry.
We did a method previously, right? The one of the student mentioned. At this, if we make it capital U, will it?
So then the entire word will become uppercase.
Got it.
Because here we're matching the entire word. So capital U will make everything uppercase.
So just to clear, the and is for whatever we referenced last.
Yes, whatever we matched in the search, entire thing is given here.
If we have say multiple groups, will the last group be taken in and?
No. The entire thing that you have matched, the entire thing will be given in hand. If you want groups, you have to use back reference, back 1, back 3, etc.
Okay, so understood. But if we use and, that would only mean the last group, right?
No. It means the entire thing that you matched. If you have 10 groups, it will mean the entire thing. If you have things outside groups also, everything. Everything between the / and the / that is matched, that will be coming here.
Okay.
Right. So, okay, let's move on. So,
can you rerun this command that U and capital U?
Yeah. If you have capital U, then
groups, right? A to Z.
Yeah, so we are matching word, anything that is between word boundaries. So any letter between word boundary, that we are making the entire thing uppercase. So here everything becomes uppercase. Whereas if we make it lowercase u means only the one letter should be uppercase. So because we are matching each word, so each word is one match. This is a match, this is a match, this is a match. So for all these matches, the first letter becomes uppercase and everything else remains as it is.
Ampersand symbol, and symbol.
And symbol means everything that we match that will be put
What
here.
if we don't give and symbol?
Then you will not have any output at all. Your output will only be punctuation symbols. So replacing words with nothing, right? So basically deleting all the words. So only the space and the punctuations will be left.
Okay.
Yeah. Hopefully this is not your like reaction after seeing the OPPE. So if we use \u with capital U, it will substitute, like it will make everything uppercase. And if we use lowercase u, then it will make only the first letter uppercase. So this is one way of like making things into word case, right? So this is something is required. For example, if you want to make a subject of a mail or something like that. So usually we will make the subject of the mail as a word case. So every word will be uppercase. Although there will be a bit more nuances. So things like stop words in English will not be uppercase. So things like a and the, those will be lowercase. So that also you can try to do it here. So you can also list out stop words and you can say substitute, or let's say capital the with lowercase the. So that is also one thing you can try after this. So write some English words here, like English sentence, and do this same thing. So it should make all the words uppercase, but things like a and the, they should remain in the entire thing as lowercase. That you can try as an exercise. All right, so let us quickly touch up on the branching and labels, and then let us move into awk. Right, so let me remove this. So in sed, we don't have any loops directly, but basically we have a more primitive implementation of loop, which is called labels and GOTO. Right, so when you basically write in a high level language, that is also translated into assembly, and there also the loops are basically broken down into labels and GOTO. So how does they work? You basically first put a label and you define, let's say you can write any name of the label. So the label name can be anything like label 1 or loop or anything like X. So we use X, right, like usually because it's just a single character, but this can be anything you want. So this is name of a label. So this by itself does not do anything. So if you simply run it on your words, you will not get any output because this is not a command. This is just a way for you to mark that this line is where my label starts.
So it will be like for loop, right?
Okay, so it's similar to, but it is not exactly a for loop, right? So you can implement labels and GOTO like a for loop, but you can also implement it like a if condition. So don't think it directly as a for loop. So label is basically just you announcing that this line is called loop 1, 2, 3. Right? So I can call this as line 3 because I can see this is line number 3, but I can also call this line as loop 1, 2, 3. Right, so I can then later tell sed to move the control back to this line by using this name.
So it's like while condition.
See, so we can do this, we can use that as a while loop. So I can obviously tell it to do, let's say, some command 1, command 2, and then I can go to this loop 1, 2, 3. So here it is like, this is the line, and then I am doing this, I'm doing this, and then I'm doing this. So I'm coming back here. So this is like a loop. But I can also use this as a if condition. So I can, let's say I have some conditions. I'm doing some substitution, and if that substitution is successful, then I go to, let's say, some loop, like some label. Otherwise, I don't go to that label. And here I do, let's say, command 1, 2, 3, and then I put that label. So here this is not a loop, right? So this is kind of like a if condition. So if this was successful, then I go here. So I skip the command 1, 2, 3. I directly go to command 4, 5, 6. But if this was not successful, then I first do command 1, 2, 3. Then I do command 4, 5, 6.
Okay, it will be working like a default printing as well as loop, right?
It's not just loop. So that's what I'm trying to explain. You can use it.
It can be used in different ways.
Yeah, it can be used as a if condition also. So here, if you're using it this way, it will be either print like do this and this, or skip this and do this. But you can also make it either do this or do this by basically putting another GOTO. So let me think how we can do that. So if I am from here, if I'm going here, then I'm skipping this. Otherwise, if I'm coming here, then I can, let's say, I can branch to another label, and that can be after this. Right. So this basically means if this substitution was successful, then I am conditionally branching to X. Right. So these two commands were skipped. So I'm directly in X. So I will run directly the command 456. I will not run command 123. Whereas if this was unsuccessful, if this substitution was unsuccessful, then this branching will not occur, right? So then we will come down and we will execute command 123. And then because we have this branching, we will come here.
Okay, fine.
There's a lot of disturbance. Just give me a few minutes. I'll be back. Okay, hopefully it is a little less now. Okay, so hopefully this makes sense, right? So if this is successful, then we directly go to X and we skip over this command. Whereas if this is not successful, then we do this command, and then because of this branch, we go to this part, right? So then we skip over this command. So we can use labels and go to as a if else. We can also use it as simply as a if. We can use it as a loop also. So labels and go to are a more like primitive and more powerful or more generalized thing, and you can use it in any way you want. So you can use it as if else, you can use it as while loop.
So can you explain tx, what is tx, what is ty, and like it is written command 1 2 3 4, like is it overall I want to know what is being like control flow, how it is going, like, and what is the meaning also, like tx and command 1 2 3 4.
Yeah.
So T is for then, right? Like then it will work, right? Or
yeah. So T means it is a conditional branching. So so here actually we don't need T, it can be B. So what T and B difference is, B means whenever I put, let's say, by, it means go to the label y. So whenever the like flow comes, right? So the flow will come like this line by line. So whenever the flow comes to this line, by simply means go to the label y. So it will not do these two lines. It will as soon as it comes here, it will go to this label, and it will do, if there is any other command afterwards, it will do that. T means it is a conditional branching. So T will only branch to the label given after T if the previous substitution was successful. So here, if let's say substituting something like this with something else, so I'm not giving any like meaningful data because it doesn't matter. It will work for any substitution. So if this substitution was successful, which means if this kind of pattern was present in that line, then the substitution will be successful, and only then this tx will branch to the label x. If this was not successful, then it will not branch to the label x. Then it will keep on going line by line. So then it will execute command 1 2 3. Right. So I think
if condition is taken from the one line upside where T is written.
Yes. So yeah, this is basically, so this entire thing is the if, right? So this is the command, and this is what happens if the condition fails, and this is what happens if the condition succeeds.
Okay.
Sir, could you change the x to if? Then it will be understandable, right?
X to if.
Yeah.
So this is not directly correlated to if. So this can be any label. So
No, just to make them understand. It will
it will cause more confusion. So if you write it this way, this seems that this is a keyword. So that is exactly what I don't want you to think.
Okay.
Yeah, this is simply a label.
I understood, like T is what then? If the condition
the T is kind of like an if. So I can say that this T, the T is kind of like an if. So it is like a conditional branching. So only if the previous command is successful, it will branch. If this is not successful, then it will not branch.
Yeah, it will go to the default command 1, 2, 3, 4.
Yeah,
right?
it'll keep on going down.
So it's like try and except in Python, right? Like kind of if this is successful.
Not really. So this is like if else block. This is not like try and except block. So you can basically you can think of it like a try if you're thinking that this will throw an error. So if you say that the substitution will throw an error, and then if it throws an error, then you do this, otherwise you do that. Yeah, in that way also you can think of it as try and except. So basically it's control flow, right? So try, except, while loops, if loops, those are all higher level language concepts. Everything boils down in the lower level into GOTO and loops. So you just mark some lines as some labels, and you ask the interpreter to go to that line for some condition. So here this B is unconditional, so it will always go to the label by.
Okay, thanks.
So can you hear me?
Yeah.
So in short, if the substitution works, the command 1, 2, 3, 4 line will run, and if it does not work, then command 4, 5, 6 will run.
No, the opposite. The opposite. See,
Okay,
if this is successful, then it will branch to X, right? So this part is skipped. So 4, 5, 6 will be done. Whereas if this is not successful, then this will not
command 1, 2, 3, 4 will.
Yes, and then because we have this by, so this will not be done. So then it will come here.
Okay, thank you.
Right, yeah. So we can also have a simple if loop. So only do something if something was correct, which we saw earlier. So this is like a if else loop. So we are basically doing either do this command or do this command. So any logical control flow we can establish using like labels and GOTO. You can also have loops, as we saw. So if you basically have the label on the top and you have some commands, right? And then if you have a conditional branching, like branch to the label. So what this will do is it will execute these commands, and let's say this command, it is like a sed command, right? So this is sed something with something. So if this substitution was successful, then it will again go back here, right? So it will keep on looping. So as long as this substitution is successful, this will keep on looping. When this substitution is unsuccessful, then it will basically move on. So if there is nothing else in this line, it will go to the next line. But if this is B, then this basically becomes an infinite loop, because I'm telling unconditionally always go to label. So this is an infinite loop. Doesn't matter whatever we have inside. Unless we have, let's say, something like an exit or something, or something that will cause the script to crash itself. Otherwise, it will basically be an infinite loop. So for loops, we usually use P to conditionally go back, so that we can have a controlled loop. So let us see some examples so that it will be more clear, right? So this is abstract. So let us see one or two examples.
After T and B, can we use a space to give the name of the label?
Yeah, that is fine. That is fine. So let us see that also. So let me create one example file. So that is also one of the questions that we have given. So let's say we have a file where we have some lines, and we have full stop at the end of the line. So the line has ended. But let's say some lines are very long, and I don't want to make a line this long. So what I can do is, instead of making it this long, I just put a backslash here and go to the next line. So I internally note to myself that wherever I have a backslash at the end of the line, that means the line has not ended. I have simply folded it into multiple lines to make it look good. But this entire thing should be considered as one line, right? So obviously this is not one line, these are two lines, but I can then use this backslash as at the end of the line to reconstruct that. So that will be what we will try to do. So let me add a few other lines. Hopefully this makes sense. So this should be one line, this is one line, this is one line, and this is one line. So there should be 4 lines and 2 empty lines, total 6 lines. So if I want to now unfold these lines, so we have to basically use a branching. So if I knew there is always 2 lines are consecutive, and I always want to simply join two consecutive lines, then I can do it without any labels. Right? So for example, we can use the capital N command that takes the next line also in the pattern space. So the first line will be the first line in the pattern space. And if I run the N command, instead of creating a new cycle in sed, it will simply take the next line also in the pattern space. So then this entire thing will become our pattern space. So when we read one line in a pattern space, like by default, we don't have the \n in the pattern space. So here, if you try to substitute \n with something, trying to make two lines into one line, that will not happen. Only if you first read the next line into pattern space, only then you have the first line, the \n, and the next line. So only then you can substitute the \n with, let's say, space or something. So if I do,
sir, are you saying that in the pattern space, if like a script is being executed from start to the end, so in the pattern space, these lines are being accumulated or these are removed after processing? Like one line is read and then second line is read and then first line is removed from the pattern space, or it remains in the pattern space, like third,
so
fourth.
by default inside, it will read one line. It will do all the things that you ask it to do in the command. Then it will remove that line from the pattern space and it will add the next line. But here we are forcefully taking the next line also in the pattern space. So we are not removing the first line. We are taking the next line also in the pattern space. So when we do that, it also has a new line between the two lines. So only when
it
we
has the \n character if we read the second line.
Yes. So then we can substitute that with space to join that. So if I do this, it will simply do it for all the two consecutive lines. So let me run this on folded. So, and let me also print it. Let me remove this. So here you can see what it is doing is it is simply always joining two consecutive lines, right? So this hello, how are you? And some lines are, both of these are now present in one line. So how did this happen? So for the first line, which was hello, how are you? It got the N command. So it also appended this next line. Some lines are in the pattern space, including this slash also. And it substituted this new line between the first and the second line with a space. So that's why we got hello, how are you space. Some lines are \. But because we then added this line into the pattern space already using the N, in the next cycle, it will directly start from this line. So then it starts with this line very long and it appends this next line, which is a empty line. And then it again substitutes new line with space. So we have very long and a space. So it's not visible here, but it is there. So then again, it starts with this line and it appends them. So here you can see it is correctly substituting this. So it is doing, this is another example of line, but it is stopping here, right? So it is only doing two consecutive lines always. So this is not correct. We should always check how many lines to take. So if we don't use any branching or labels, we can only do something for a fixed number of times or a hard-coded value. So here you can see we are always taking two consecutive lines and joining them together, and then again taking the next two and joining them together. Whereas here we can also, let's say, do another N, and now it will take all the three consecutive lines and join them together. So you can see, and we also have to substitute all of the new lines with space. So now you can see it has taken the first three lines and put them together. Then the next three lines. So this empty space is because of this empty line. Then this is the second line, and this is the third line. So this is now doing all the three lines together. But obviously, this is also not what we want. So we wanted a variable number of times. We want, in this case, we want to not join anything because this is a line itself. In this case, we want to join these two lines. In this case, again, we don't want to do anything. In this case, we want to join these four lines together. And again, do nothing here and join two lines here together. So if I want to do it a variable number of times, here we have to use a branch and label. So let us see how we can do that. So here it is kind of like a loop. So we will set the label at first. And then I have to first check if there is a backslash at the end of the line. So I check if there is a backslash at the end of the line. So this dollar means end of line. And backslash is a special character. So we have to escape that. So we do backslash. So this is backslash at the end of the line. And if there is a backslash at the end of the line, then, so this curly bracket basically means do everything inside it for this. So if this is true, then do all these. So then we can do few of the things. So we can first take the next line then, so, right? Because we know if there is a backslash at the end of the line, then we need to have the next line in the same line. So first we take it in the pattern space, and then we substitute the backslash n with nothing, right? So we are substituting the backslash and the new line with nothing here. And we don't need to do it globally because we will always have one new line because we are doing it one by one. And once we do this substitution, then we will branch to the X. Right, so only when there is a backslash dollar or like a backslash at the end of the line, then we read the next line, substitute the new line with nothing. So we basically join the next line with this line, and then we go back. Right. So why are we going back? Because we might not be done. Right. So for example, in this line, if I simply join this line and this line, that does not mean we are done with the folding, right? Because two more lines are left to be folded. So we will again go back and we will again check. Right. So when we are branching and going back, the pattern space is not cleared. So pattern space still contains this entire line. And obviously this backslash has become like backslash and new line has become one line. And now we are again checking, is there a backslash at the end of the line? So again, a backslash is there at the end of the line. Right. So again, we will go inside and again, we will join the next line. So now the pattern space becomes this, where these two have been changed into like they have been unfolded. So again, we will branch and again, we will check if there is a backslash at the end of the line. So again, this is true. So again, we will append the next line into the pattern space and unfold it. So we keep on doing this. So now in this case, you can see once we again go back, now it will check, is there a backslash at the end of the line? And no, right? So there is no backslash at the end of this line. So then this will not occur and it will basically finish off with this cycle. So then this entire pattern will be printed without like the backslashes and the new lines. And then it will go on processing the next line. So let's see how the output of this looks. So now you can see it has basically folded the lines correctly. So the first line remains as it is. The next line is two lines that has been folded correctly. Similarly, again, third line, empty line remains as it is. And this line with 4 folds has also been correctly unfolded. And again, this line with 2 folds is also unfolded. Right. So here we can use labels and GOTO to basically unfold a variable number of folded lines. So just let me know if this makes sense.
Sir, here instead of bx, if we use tx, it should also work, no? Because
Yes.
we're only branching when.
Yes, both will work. So here, because we have first checked a condition and then entered inside, so we basically know if there is a backslash at the end of the line, then substituting. So if we then use n, so then we will have a backslash n. So substituting backslash and backslash n will always succeed. If this is true, then this will always be true. So thus T and B will give you the same result in this case.
Also, if we put curly braces on top of the label, like after starting the label and then at the end, would that be syntactically correct?
I'm not sure. Let me check. So you're telling like this, right?
Yeah.
Okay, so let me see. No, so this is not correct because this is part of the label itself. So I think this may work, but yeah. So this is basically being treated as the part of the label name itself. So you cannot use a curly braces.
What if we put space after that?
Okay. Let me... Yeah. Okay. Yeah. This works. Yeah, this will.
Sorry, if you put curly braces in next line, like 4th line, it will work.
Like this?
Yeah, it will be better.
Yeah, this will also work. But then this is not like doing anything, so we don't actually need this.
No, it will be making some sense, right? Good looking. That's just.
So that will give you a wrong sense because here this is not a loop by itself, right? So we're simply stating a label and going to a label. So here this braces are not doing anything. So this is all you need, because here we are using this if. So everything inside we are doing it only if this is true. So that's why we use a brace here. But this is simply a label, so you don't need a brace there.
We have 3 backslash character, and then that should be 2, right?
So this is the backslash character. So we have escaped the backslash character, and this is the new line backslash n.
Oh, okay, got it. Thank you.
Sir, we don't need to give a G right at the end of the 6th line.
No, because every time there will only be one backslash n. Right? So every time we are taking one line in the pattern space, and immediately we are substituting that new line with nothing. So everything there will just be one new line in the pattern space. So we don't.
But n is for default, like default 1 line, and n is for 2 lines, right?
Sorry, can you repeat that?
N is for like extra 1 line we are taking as a buffer, right?
Yes. So see, when you have just one line, this is your pattern space. You don't have a new line at the, so the new line is not read in your pattern space. Only when you use n and get the next line, then the new line between the first and the second line, that is read. So this new line will not be read.
Okay, new line will be at the start of the line.
Basically in the between the two lines.
Okay, fine.
Yeah. Right, so hopefully this
So
makes
Sahil, just one thing, apart from this, from OPP, like how much percentage of my marks would be from the branching?
Usually branching is not asked in OPP, right? So you you will not get any question like that. So said questions will be simple, like you have to do some substitution, or at max maybe some transliteration. So you will not be asked to do something.
At max,
Yeah. Sorry?
At max, what you said? I just missed it.
Substitution and transliteration, right? So the one we saw, Y.
Okay.
So that is also rare. So usually you'll get like printing, deleting, substituting, that's all.
Sir, should I expect like sed and awk commands only in my OPP2 or some other things?
No,
similar
was
to
also
this.
included.
Yes.
Okay,
It will
and
be similar
we
to
don't
this.
have choice, right?
No, you'll have all 6 questions you have to attempt.
Wow. Okay.
Yeah. Okay, so let's move on to awk, right? Because
Sir, I have a question. I was solving OPPs, not OPPs. Somewhere I saw this question. I'm posting a string in the chat. It's an HTML code, and we had to remove all the tags. Like B tag, you have to remove the ending B tag, and the A tag, you have to remove ending A tag. So what kind of approach would you take with this?
Let me see. So we have to just remove the tags, right?
We have to remove the tags, just the information we have to get out.
The content should be there between the tags. Yeah, so then you can simply use substitution, right? So you can substitute any character that is between a left angle bracket and optionally / also. So we will escape the question mark because this is ERE, or you can use ERE. So let me use ERE itself.
We can.
So left angle bracket and maybe a / maybe not, and then any alphabet. I'm assuming tags can only be alphabets.
Or could you just remove -e? Without that, could you explain? It will be better, I guess.
Yes, everything will be same. You just have to escape this question mark. So if you substitute left angle bracket and optionally a / and then any letter present any number of times. Yeah. So I'm assuming minimum 1 will be there. We can also use star if 0 is not there. And again the closing bracket, and I simply substitute that with nothing. I think this should be enough, right? So what did we miss? Unknown option to S.
Sir,
my bad.
escaping is altered.
Yeah, we have to escape that. Okay, so we have to also add a G here. Right, so this seems to work, but then this A tag is not working, right? So we have to remove this entire A tag, right? Like
yes.
Yeah, so instead of A to A, I think we have to use basically something that is not the closing tag. That should work. Table is an arrangement of information or data. Yeah, looks correct, right?
We can also use dot star, right?
Dot star
between two
will
angle bracket.
also match the closing one, right? So I think that may not work. Yeah, so it will remove everything totally. So dot star is not fine because I want to match anything like from this angle bracket till the closing angle bracket. So I don't want to
Oh,
match
right.
till the end.
It
So I
will,
should I should match
Sorry,
any
use
character
dot,
except sorry.
Use star. You to just give dot.
No, I give dot plus. Dot star will also do the same thing. It will also do the same. So I need to match any character except the closing angle bracket. So opening angle bracket, optionally slash for the like closing tags, and then any character except closing angle bracket present any number of times, and then the closing angle bracket. So this entire thing we substitute with nothing. Right? So then we will get this. Yeah.
Can I go like this dot star and then can I negate that using cap and brackets, square brackets?
So what you want to do? Dot star and then
cap and keep that inside square brackets.
Okay, like this.
But Sayan,
That is not going to negate it.
in
Outside.
the
Negate.
Yeah. What do you want? Dot star and then
Cap and inside that I'll have this angular brackets inside bracket. So I'm basically negating the angular brackets.
Yeah, so
after
like this, right?
Yeah.
Yeah, so this will not work because you are telling dot star, which means any character any number of times. So you cannot give dot star. You have to give not angle bracket. So you got this part right, but you cannot give dot star. You have to give not angle bracket present as many times as possible.
Oh, okay. Got it. Okay.
So you have to do it this way. Yeah, already.
Yeah, I was asking that the command that is working, why is it we are negating the angle bracket, right? So why is it not directly matching the last angle bracket?
No, it is matching the last angle bracket. See if you are doing with dot star, right, or dot plus. So what it will do, let me find the data. So the first match is where in this, actually I don't have to scroll. The first match is here, the opening bracket. And then if I say dot star or dot plus and then a closing tag. So what is the biggest match? This is the biggest match.
Yeah, right.
So it will remove everything. So it will be A space comma. That is what we were getting, right? A space comma. So if we do if we match dot star closing angle bracket, it will match as much as possible. So it will match everything. So what we need to do is we need to tell not dot. So not any character except the closing angle bracket. So you cannot include the closing angle bracket and keep on going forward. So you can match as much as possible only till you find the closing angle bracket.
Right.
Okay, so this is like a general way of matching any like opening and closing thing. So this is useful for matching quotations, useful for matching like HTML tags this way. So anywhere where you want to match starting some delimiter and then anything between them, that is obviously not that delimiter, and then the ending delimiter. So you put the starting and the ending thing as a not, and then the ending thing. Right. So you match the starting delimiter, any character between that will obviously not be the ending delimiter, then the ending delimiter.
It's better to use ERE. ERE is much cleaner.
Yeah, if you have ERE, it will help you understand things better because you don't have
first
to.
ERE, then convert it to BRE because
not this dot. Sorry,
easier for the mind, right?
Yeah, this was like this. Yeah, and here you can also forego escaping this forward slash if you use some other character here itself. So you can do this. This is the simplest.
What is this?
So in sed substitution, you don't actually always have to use forward slash. It can be any character given that it is same. So if you're using pipe here, you have to use pipe here also. So if you're not using forward slash, then forward slash does not have a special meaning, right? So then you don't need to escape it anymore. This can be any character. It can be like colon also. This has to be the same.
Yeah, it just has to be not part of the HTML tag in this particular context. You use something which is not likely to appear. Or not
No, it does not have to be not part of the HTML tag. It does not have to be. It should be not part of the regex that we are writing. If
Right,
it's
right.
part of the HTML, it is fine. It should not be part of the regex that we are writing to match that.
Correct.
Yeah.
Sir, but the escape character is always forward slash, right?
Escape character is always backward slash.
Okay. Okay.
Yeah. Yeah. So hopefully this answers your question. How we can
Thank you so
extra.
much.
Yeah, sure. Okay, so let's move on to awk because we have already spent 2 hours on sed.
Yeah, and one question on OPP sign. You said 222, right?
Yeah.
From each. So
around 222, yes.
Okay, around 222. So even the marks are distributed
What
equally.
are these topics? What are these topics? 2 to
Awk,
2 means.
awk, sed, and bash.
Yes.
Okay. Okay.
So even the marks are equally distributed, or do sed and awk have more weightage?
No, the marks are usually like 15 times 4 plus 20 times 2, right? If I'm not wrong. So
Yeah.
15 times 4 is 60 and this is 40, total 100. So you'll have 2 questions of 20 marks and 4 questions of 15 marks.
Okay, so I presume those 2 questions are sed and awk of 20s. And
that I am not sure. So that
can be
anything.
anyhow. Okay,
Yeah,
got
that
it.
can be anything. Yeah.
I thought there was a particular pattern, so that we could.
Would we be
focus more on-
getting questions from tarball, zipping, GZ?
Yeah, that is also part of the syllabus, right?
Okay.
Very good.
Because in the morning today's session, sir, in the 2 to 4 p.m. session, he said that won't be asked. So it's
Okay.
not. So
Okay.
it's not
Yeah, he
true,
was saying
or
it's okay,
what
but-
do
No,
we take?
no. If sir told it won't be asked, then it won't be asked. But then it is part of the syllabus. Is what I said. Yeah.
Okay. Thank you.
Yeah. I don't know what are the questions, so say what will be there.
Hello, sir.
Yeah. Okay. So let's move into awk now. So just like we have the sed website, we also have a website for awk. So awk is basically like a programming language in itself. So I will not go over all the commands of awk again because we have already seen these. So let us see some of the important things that we can do with awk. So the way of writing awk scripts is exactly same as sed scripts. So we create a file which can have any extension. But the important thing is the shebang should say /bin/awk or gawk, whichever you're using. So usually awk will be symbolized into gawk in most systems. So gawk is GNU awk, which is the flavor of awk you will get in most GNU Linux operating systems. So here in awk you basically have blocks. You have a begin block, you have a end block, and what is happening? Okay, and you have a begin block, you have a end block, and you also have any other blocks where you can put any pattern. So for example, I can put pattern like let's say this E letter should be there. So I can say for all lines that match this pattern, do this following task. So this is kind of similar to sed, how sed works. So you can see we can give any regex. We can also give line numbers. I can say 1,5. So from line 1 to 5, do something. So let us create a few files to see how it works. So let me make the A to Z. And let me make, let's say, numbers. So we have a letters file which has A to Z, and we have a numbers file which has 1 to 100. So if I run this script, so first I have to make it executable. If I run this script on, let's say, the numbers, and I say for lines 1 to 5, simply print those lines. So here we use the keyword print to print lines. So if I do that, why is it printing everything? Let me use regex to see if it's working. So let's say for lines that have the number 4, print those lines. So you can see that lines that have the number 4, so 4, 14, 24, 34, 40, and all the 40s, 54, 64, etc. These are being printed. I think the number range is a different way. I forgot how it is. Yeah, you can use the NR in op instead of giving a number range directly. So here I can say if the number range is the number of records is greater than 4 and the number of records is less than 10, then print. So what this will do is it will print from line 5 to line 9. So this way we can print based on the line number. So here we cannot directly write 4 comma like 5 comma 9. We have to use the NR variable. So NR means the line number. Or we can use a like regex here. So I can say anything that matches 4, we print that. So here this uses extended regex by default. So you can see if I give 4 plus, plus does not mean the plus symbol. It means 1 or more than 1 4. So you can see we are directly getting the answers without having to mention capital E. So awk by default uses extended regex. So here I can also do things like 2 or more. And for all the lines that has 2 or more 4s, print that. So why is this not working? Okay, I forgot the opening brackets. Sorry. You can see it is only printing the line 44 because there is only one line from 1 to 100 that has 2 or more 4s. So if we make it 1 or more 4, then it will print all the lines that have 1 4 or also lines that have 2 4s. But if I make it 1 comma 1, then what should it print? What should be the
4, 14, 24 like that.
So should 44 be there?
No.
Okay. Let's see. So 44 will still be there because here we are matching regex, which says that there should be exactly 1 4. So in 44, there is also a regex like a pattern which is exactly 1 4. There are 2 patterns which are matching. So 44 is also matching in this. So if you want to say that it has to have exactly 1 4, so if you only want to print, let's say this line, which is only 4, then you have to put start of a line and end of a line here. So this will print only that. And if you want to, let's say, print all the lines except 44, that is, you want to print any line that has any number except 4 present. So the 4 can be present only once. So then what you can do is you can do something like 0, 1, 2, 3, 5, 6, 7, 8, 9. And this can be present any number of times, even 0 number of times. And again, on the right side, it can be any number except 4, present any number of times. So what this means is any number except 4 present any number of times. Then a 4 has to be there. And then again, any number except 4, any number of times. So then if we run this, then all the numbers except 40, okay, well, 44 is, okay. So we have to also put a start of line and end of line. I forgot that. Sorry. Yeah. So now you can see that 44 will not be printed. So 4, 14, all these are there. And 43 is there, 45 is there, but 44 is not there. Because I'm telling that the line should only consist of non-4s, and only exactly 1 4, and then again non-4s. So this way we can match lines which has only 1 4.
What if we want to print all numbers except 33, 11, 22, like that?
Okay, so all numbers except numbers that have the same digit 2 times, right? That is the question, right?
Yeah, yeah.
Okay.
Or the opposite. Or the opposite.
Yeah, so we can basically do that. It can be any number, so we have to group it. So we say 0 to 9, and then we basically have the same again. So if I do this, it will only print the lines that have that. Okay, why is it not working?
11, 22 like that.
Yeah, but it is not matching anything. Why is that the case? So 0 to 9, and followed by
So
that
bracket
same.
will come, right?
Sorry?
Bracket will come? Or
Yeah, we need to group that number. So we are grouping the number. So I'm not sure if back references work in awk in this. So we'll have to look into that. So ideally, this is regex that will work. So for example, if I do cat numbers and if I do grep let's say grep key and bracket 0 to 9 and then \1. So this will basically print all the numbers that have 2 consecutive numbers. But for this awk, I think the back reference or the grouping does not work. So maybe let us try escaping them. Okay. Yeah. So yeah, we cannot.
By default, awk by default uses ERE, right? So
yeah, awk by default uses ERE, so we should not need to escape them. I think we cannot use back references inside the search pattern. So that you can
but
look
in
into.
sed it was allowed though.
Yeah,
Sed
in sed and grep, both of them, it is.
because we did the palindrome by using that, right?
Yeah, exactly. So here we can use any other regular expression, and we can also use any other comparison. So for example, we saw we can use things like NR. We can also use FNR. So FNR and NR are very same, but FNR will reset for every file. So I can do FNR equals 1 and print. So this will basically print the first line of each file. So if I give only one file, it will obviously print the first line of that file. But here I can also give the like 2 files, and for each file FNR will reset into 1 on the first line. So you can see 1 is being printed and A, which is the first line of letters, is being printed. But if I set this to NR equals 1, then it will only print the first line of the first file and not the other ones. So this is
so we can actually say print all the odd line numbers of each file because you have letters and numbers, right?
Yes, we can also do that. So we can say FNR mod 2 equals 1 to get the odd line numbers. I run this. You can see all the odd numbers are printed, and similarly all the odd numbered letters are printed. Similarly, you can print the even numbers also, and you can also do any other like calculations like multiples of x, y, z also you can check this way.
So if the content is same, will it print once or twice?
Like I didn't get it.
If the file content is same, like both having same content.
Yeah, then it will print 2 times. So it does not care if it's the same file or like the same thing given again. So as you can see, it printed till 99. Again, it printed till 99.
Okay, so we want to get only the unique things, means we cannot use FNR.
Yeah, for that you can use associative array. So we'll also see how to do that.
Okay.
So if you just want to based on line numbers, you can do it this way. So another thing you can do that will basically be useful later on is you can check if you're in the first file or not by simply doing NR equals FNR. Right? Because we know NR will keep on increasing, whereas FNR resets from 1. So both of them start with 1, but as soon as we go into the next file, FNR becomes 1 again and NR keeps on increasing. So NR equals FNR is only true for all the lines of the first file. So you can see if I do NR equals FNR print, and if I give, let's say, letters and numbers, only the letters are printed. Similarly, if I give numbers and letters, only the numbers are printed and not the letters.
Okay.
So this way we can check if we are in the first file or not.
Okay, sir, for accessing like simultaneously 2 files numbers, can we use like %1, $1 twice, or how will it work?
No, awk will not like access 2 files simultaneously. It will first access the first file from top to bottom, then it will go on to the next file from top to bottom.
Okay, so line number 7 to 2 will be working like sequentially, right?
Line number 2 to 9. Yeah.
7 to 7.
Yeah. So this for each line. So what awk does is it will read each line and then it will see if this condition is true. Then it will do this. So for each line, it will check this condition.
Okay.
Right. So here, let's say now you want to what you ask like files common in both. Sorry, lines common in both files.
Yeah.
So let me add, let's say, a file called colors. And let me add a file called fruits. And here, if I then want to find the lines common between colors and fruits, what I can do is first for each line of the first file, I can simply store those lines in an associative array. So I can say, let's say ARR of $0 equals 1 or plus plus. So plus plus will basically store the number of times they are present, and equals 1 will just store 1 if it's present and 0 if it's not present. So both of them in this case will be equivalent, but plus plus is more useful because if you want to print the counts also of each line, how many times they're present, you can also use that. So we don't have to initialize values of arrays or variables. It will automatically work. So if I directly access this index in this dictionary, it will automatically set it to 0 if it does not exist. So for all the lines of the first file, I set the dictionary's value to be the count of that. And then for the lines where NR does not equals FNR, then we can check if that line exists in the dictionary or not. So I can say if ARR $0 is greater than 0. So if that line exists in the dictionary, that means it was present in the first file. So if it was present in the first file and if it's present in the second file also, so then we will print that line. So notice that for the lines of the first file, we did not print anything. We simply stored them in the dictionary. And then for the second file, so NR does not equals FNR, then we are seeing if that line of file 2 is also present in the dictionary, meaning it was present in file 1 also, then we print that line. So if I run this, you can see only orange is printed because orange is both a color and a fruit. And hopefully this makes sense.
That array $0 means what? Like 0 means.
So $0 means the entire line. So I'm seeing if the entire line is a key in this dictionary. So here I'm setting the dictionary with the key of entire line to be basically the count. So every time I'm increasing it by 1. So if let's say this was a line with 1,000,000 words also, the key will basically be that string with 1,000,000 words.
Got it. So it will basically the number of elements will be the number of unique lines in the first file.
Yes, yes. And the count will be the count of those occurrences.
Correct. And the second time you're saying it is basically from second file onwards, if you see any sentence that exists in the subsequent files, if it existed in the first file or not, and you're printing it.
Yes. And we can also print the contents of the dictionary this way. So similar to Python, we can do for key in array, we can print the key and we can print the value by accessing the key in the array. So here you can see this is the printing of this, and then we can see orange, mango, brown, apple, red, yellow, blueberry, magenta, green. So things that are not present at all in the first file, they don't have a count, whereas things that are present in the first file, they have a count. So you can see we are putting the colors as the first file. So all the colors have a count of 1. If they were present 2 times, let's say I change the colors and I have, let's say, brown here and then I have brown here again. So then brown will have a count of 2. So all the colors have counts with them, and all the fruits, they don't have any count because we have only set the count for the first file and not the second file.
That means if you want to create a dictionary with fruits, then you just reverse the order, right? Fruits colors, then the dictionary will contain fruits.
Yeah, so the output of that will be the same, like the what is common, but the dictionary values will only the fruits will have the counts, and the colors will not have any counts. So here we can also check it this way. You can also check it this way: $0 in ARR. I think this works once again. Yeah, so you can see if we check it this way, $0 in ARR. So the output is still the same. So we are getting orange. But now because we are checking it this way, $0 in ARR, so the file 2 lines are not even added in the dictionary at all. So if we were checking this way, ARR $0 greater than 0. So when I am checking it this way, exactly at that time, because this did not exist in the dictionary, the awk will create that entry in the dictionary. So you can see, sorry, let me save this. So you can see even the colors, they also have an entry in the dictionary, but obviously they don't have any value because I have only set the values for the first file. But for the second file also, they had entries in the dictionary. But if I check it this way, that key in array. So this is a way of checking it. So then we will, let me save this. And then we will only have the keys in the dictionary which are in the first file, and the second file ones will not be there. Right, so hope this also makes sense. Why this and this gives the same output here, but the value of the array is different in both the cases.
So why is the orange printed? Like we have an orange without a key, right?
No, the orange is printed. So this is part of this print. So because we are printing the lines that are common. This is not printed in here. If I remove this also, the orange will be there. This is what we originally wanted, print lines that are common to both the files.
Okay, sorry.
Yeah.
The FNR will be, I'm confused between the FNR code. Could you just go through it?
Yeah, so FNR means the line number according to each file. So for each file, the file like FNR will reset to 1. So it will be 1, 2, 3, 4, 5, and then in the next file it will again be 1, 2, 3, 4, 5, 6. Whereas NR will monotonically keep on increasing. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way. Right. So the NR and FNR thus will only be same when we are in the first file. So in the first file, NR also starts from 1, FNR also starts from 1. Both of them are 1 and increase by 1. Only when we go to the next file, FNR again becomes 1 and NR keeps on increasing from the last count. Right. So this is will same only in the first file.
Okay.
So that is basically how things in awk work. But the most important power of awk is being able to split data. Right. So for example, let me have a data.csv. And here if I have, let's say, name, age, gender, profession maybe. So let's add a few fake names.
You have pincode.csv.
Oh yeah, we have that also. But in code.csv, we also have the quotations. So let me do with this one first, and then we will take pincode.csv also.
Sure, sir.
Yeah. So let's start with the dummy data. So we have a few people. No, I want more data. Yeah. Okay. So we have a few data here, and now the power of awk is that we can easily split the data, and by just telling awk what is the field separator. So here the field separator is always comma. Whenever we have a comma, it means that the field has ended. So I can simply in the begin part, I can set fs equals to be comma. And now, so everything, all these will still work. But now let us now, instead of checking for common files, let us now simply print the like columns. So here, if I simply do print $1, then you can see that if I run this script.awk on this data.csv, you can see it is only printing the first column: name, Adam, Bob, Kathy, David, Eve, Frank, Grace, Helen. Similarly, if I do print $2, it will only print the second column, age. So we can use the $1, $2 inside, but we can also use it in the condition checking. So if I don't give any condition here, if I just give brace and then a command, then this will run for all the lines. So as you can see, it is basically running for all the lines. We are printing second column for all the lines. But I can also say only print for people whose age is, let's say, greater than 20 or let's say 30. So maybe we are a company which does ageism. So we are discriminating based on age, and we only hire people above 30. So we can have a condition like this, $2 greater than 30, and it will automatically, if the field is a number or if it's a string, it will automatically coerce it. So here, because it is a number, we can directly put $2 greater than 30. And here I am checking if that is true, then only we are printing the age. But I can here also print the entire line. So $0 prints the entire line. So then here we are basically printing only those users whose age is greater than 30. So you can see Adam is skipped. So we are not printing Adam, and Bob also is skipped because we are told greater than 30, not greater than equal to 30. So similarly, we can also do things like the gender. So we can say $3 equals female, or $3 equals male. So then also we can do print. And what print?
F, not female.
Yeah, sorry, my bad. we have marked it as F. So if I do this, if I just put print and not tell what to print, it will print the entire line. So here also you can see only the female applicants are being listed here. So another thing, so one thing we saw is if I do print $0, that is same as print, but we can also drop the braces totally. So if I just say $3 equals F, this also means the same thing. So this will also print those lines that match this. However, if we give a brace here, which is empty, then that means for that condition, do nothing. So just keep this in mind. If you just give a condition, this means for that condition, print that entire line. But if you give a condition with empty braces, that means do nothing for that. And if you give print in that, that means print the entire line. And if you give print $0, that also means print the entire line. So here, any condition that we give, if, sorry, let me save this. If that, why is this not okay? Oh, yeah, my bad. Again, my mistake. So if that condition is true, then that line, like if that condition is true for that line, then that line will be printed. So here we are actually checking something based on that line. So I'm checking based on $3, which is the third column. But I can also check, let's say, if 2 is lesser than 3. So this is also a condition. And this condition is independent of the line, right? So this condition is always true. So if I run this, you can see all the lines are printed. So this is one way of printing all the lines. And we can simplify this even further. So here we are using a conditional, but I can directly make this, let's say, as 1. So if I just say 1 basically evaluates to true. So this will also print all the lines. So basically an esoteric way of printing all the lines, but you should be aware how this works. So any condition that we give without any curly braces means if that condition is true, then print that line. Otherwise, don't print that line. For example, I can also say $4 equals CEO. So only for people who are CEO, print me their values. And I can also combine multiple conditions. So for example, I can say $3 equals M and then $4 equals CEO. So then it will print only Frank, who is male and CEO. And I can also use or here. So print people who are male or they are CEO. So both the CEOs are printed and the non-CEO males are also printed. So any like and or that you want, you can do in this condition. And in here, if we are using print, what print will do is it will put a new line after printing everything. So print by default prints the entire line, but I can also just print the name of the applicants. I can do print $1 and it will just print the name of the people. Whereas we also can use printf. So people who have done C will know how printf works. So you can give any string formatter into printf. If I don't give anything, if I just give $1, so it will basically print everything side by side. So it does not automatically give a new line, but I can provide a new line by simply putting a \n after it. So here you can see it's same output. So in awk, we do string concatenation by simply putting two strings side by side. We don't have to use a plus symbol. That is wrong. We simply put them side by side. If two strings are side by side, that means concatenation. So I can also make this, let's say, tab. So I can have them tab separated. But then this also breaks my prompt, right? So then the next thing that we come across is the end block. So if I have to do something after processing all the lines, I can put that in the end block. So here I can say simply print a new line character after printing all the records. So you can see after the end, we got our prompt back on the new line, but the records were printed in a tab separated manner. So similarly,
same.
Yeah.
Print and printf.
Yeah. So print will put a new line after printing something, whereas printf will not put that new line. And we can also use string formatter here. So for example, instead of doing $1 and %t, what I can do is similar to C, I can do %s\t, and here I can give the %s value to be $1. Right. So this also works the exact same way. So %s basically is a string.
Python also has the same thing.
Yeah, we can do it.
Format.
Yeah. Similarly, so if we want a number, we can use %d. So let's say the age I can give. So, and if you want a string, we can use %s.
So here we can calculate how many people or applicants, whatever, or employees, male, female, or
yes, exactly. So that is the next thing. So another useful use of the end is basically to show the statistics. So let's say for every line you don't want to print anything, you simply want to do some statistics. So you can also do that. So for example, I can say if $2 is, let's say, greater than 30, I can say let's say experienced plus plus. And similarly, I can say $3 is equals M, then male plus plus. So these are simply counters that I am increasing, and I don't have to set it to 0 because awk sets things to 0 by default. And I can say, let's say $4 equals CEO, or let's say $4 equals politician. So then we will say high post people plus plus. So then in the end, what we can do is we can simply print all these details. So we can say experienced these many people. Similarly, male is these many people. Okay, so one question: how do we print how many females there are?
NR minus
number of records minus
right.
We can use calculation, subtraction.
Yes. So what will be the formula?
NR minus male, right? Or
NR minus male will give you the, yes, exactly. So it will be close but not correct. You have to do NR minus 1 minus
-1, yes.
Okay, because you have a header, right? So this is also assuming like regressive assumption that people can only be male and female. But let's just assume this for a simple example. So you can calculate directly if like you're having a Boolean variable. So you can calculate the stored value of 1 and calculate other by doing NR minus that if there is no header. And if there is a header, then obviously NR minus 1 minus that. Similarly, we can print.
What is header?
Sorry?
Like what is header? Is it like
this line is the header, right? Which is not a part of data. So if we have 1, 2, 3, 4 males and 1, 2, 3, 4 females, so number of lines is 9, right? So 9 minus 4 will give us 5, but that is not the number of females. So we have to subtract this header also.
Okay.
If I run this now, you can see we're not. Yeah.
the NR is increasing counter, right? Or is it like a single variable?
No, NR will NR is a variable, but its value will automatically increase after each line. So in the first line, NR value is 1. In the second line, NR value is 2, and in the last line, NR value is 9. And in the end, the NR value still remains 9 because the last line it was 9, and it does not change after that.
Okay, thanks.
Yeah.
So similarly, we can calculate the average age of male and female also, right?
Yes,
Like
we can
that.
also do that.
So
So
salary or whatever. So we're just using something numeric, right? So
yeah, so we can do something like male age plus equals this, and similarly for the female age also maybe we can add. So we can say $3 equals female, then female age plus equals this, and then we can say, let's say, average male age. So that will be male age by male, and average female age, what will that be?
female is divided by NR minus 1 minus male.
NR minus 1 minus 12.
So we have to use printf, right, here?
No, we don't have to use printf because here we are simply printing a string concatenated with a value. So print will work.
Integer, right? We want decimals, right? The average is.
Yeah, so it is printing decimal only, right?
Okay, directly it will print. Okay, default. Okay.
Yeah. So if you are like dividing something, it will get the decimal value and it will print that. So you can also change like how the decimal value should be formatted by setting a field called OFMT, output. Forgot what is the full form of it, but yeah, OFMT, which will basically let you change how many decimals, etc., to show. So for example, if I set this to let's say 6, then I think this will still not show because we are doing concatenation here. If I instead put a comma here, then you can see that, yeah, so it is showing that field with that many zeros. So let me put a comma here also. So if you put commas in print, that means it will basically separate those as separate fields. And the default field separator is a tab. So you can also change that. If I set OFS to be, let's say, comma, then they will be separated by comma. You can see we have a comma here. But by default, the field separator is a tab. So you can see we have this colon and then we have a tab. So if we have separate fields this way, instead of concatenating a string and a number, so then print will use the OFMT to format the number correctly. So you can see we are always getting 6 digits. Similarly, I can set it to 2 also. So then we will always get 2 digits.
Sir, suppose if they are asked to give the median of the ages, and
yes.
How will we do that, sir? Like we will store it in an array and
yes,
sort it, and yeah, can you show that, sir?
So storing it in an array is simple. So for sorting, you simply need to use the asort function. So we already have one question on this in the VM, so which is I think the we have in the NPP, right? So in the NPP last NPP, so you can go through the solution for that. So what we basically do is we just store each value one by one in the array, right? So for example, let me quickly show that. So let's say for all the lines, we simply say age of nr minus 1 equals the second column. So I'm just storing the age, and then I simply have to sort the age variable. So then I can say that the median age is nr by 2. So this is obviously not always true. It will depend if it's even or odd. So you have to do that calculation. But I'm simply showing that you can, this way you can get the median age, which is 40.
Yes, sir.
So, sixth line we can give nr greater than 1 to better.
Yes. Yeah, you can do that. Yeah, you should actually do that nr greater than 1. So only for non-header we are calculating. Yeah.
nr should be equal age nr, right? Or it should be minus 1.
No. So because in the second line the nr is 2, but I want to index it from 1 itself. It's another important thing to note about OP is that arrays are indexed from 1 and not from 0.
Not from 0. Okay.
Yeah. Even strings. So you have string functions also in awk. So for example, you have things like index and match for doing regex. So those also will be 1 based and not 0 based. So everything, even the columns you saw, right? So $1 means the first column. So everything in awk is 1 based and not 0 based.
And line number 10 is the right begin line. So there you are given the curly braces adjacent to the begin, right? If we put it in the next line, will it work?
Yeah, that will also work.
It's showing for me it was showing error. That's why
okay, yeah, it is. Actually, I've never tried that. Yeah, I think you cannot do that. It should be in the same line. Yeah.
Okay, yeah.
So that is basically the syntax of awk.
Okay, I thought it's issued by.
Yeah. Right, so now let us try the sum. So this was a simple data set because comma always means a field separator. But you have also seen there are files that have comma in the fields and also as field separators. So one such file I think is the pin code file. Let me see if we have. Okay, this is my local system.
OPT assets.
Yeah, I'm not in the VM, but I do have it somewhere. Yes, I do have the pin code info. So let me just copy that here. So I have this pin code info. So let me open this first to just show you how this file is if someone is not familiar. So this one has like a circle name and then region name, division name of places, office name, pin code, and the office type, the delivery type, the district and the state name, and this is for the entire India. So it has around 19,000 columns from all these states. So now if I actually see this data, this pin code data, so here you can see there are some, I don't think I can see here right now, but then there are some lines which has comma in the field itself. So let me see how we can find that. Yeah, I can find it this way. Okay, I don't think this one has that. I think this is a simplified.
Hyphen O we have to give, right?
Sorry?
Hyphen O we have to give, right? Only the lines.
No, hyphen O is not required in this case. So here I think this data set is the one which does not have any commas in it. This is a simplified data set. Let me copy another data set. Yeah. Yeah, you were saying something?
Yeah, I think you could make a copy of this and you can edit 1 or 2 lines with a comma in between. Like
yeah,
these
but then I have
comma
already a data set. One second, let me just find
okay,
that.
okay, fine. Sure.
I have something called Spotify data here. Let me just copy this. Yeah, so here I have this Spotify data set, which let me quickly show. So which is basically one of the additional questions. So it has the track name and then the artist name, artist count, and then a lot of information about each song. Right, so these last few columns are numeric, so obviously they will never have commas, and these also are very structured. But then this artist name, right? So as you can see, most songs are not written by one artist; it is written by multiple artists, and this is also separated by a comma. So if you see this data, you will see that this artist names where there are commas, it will be quoted. So you can see this is inside quotations. So for lines which has only one artist like this one, here it is not quoted. But for lines that has multiple artists, then that field is quoted. Right. So these kind of CSVs are like partially quoted CSVs. So all fields are not always quoted, but some fields are sometimes quoted if they have a comma in them. So in this case, if we simply set the field separator to be comma, then it will not work. Right? So this will consider this as first field, and then this as the second field with the quotation, and then this as the third field, and this as the fourth field. So it will only it will give random columns for each lines. So in that case, you have to basically use a field called or a variable called fpat instead of fs. So let me remove all this. There, what you have to do is you have to use a variable called fpat. So fpat means the field pattern. So instead of telling of that split each field by a particular symbol that separates each field, I'm telling that each field will follow a regex, and however time you can match that regex, those are the fields. Right. So this is how you can match, you can match columns of partially quoted CSV files. So what we are telling is this pipe symbol means this is one regex or this is one regex. So we are telling either each field is basically any character except comma as much as possible, right? So for example, you can see these numbers. So this is any character except comma. So this match starts here and ends here because then there's a comma. So again, then this is the next field. So any character except a comma as much as possible. So minimum one character as much as possible. So this is one type. Another type is for the fields that are quoted, right? So there we have a quotation. So we have a quotation marks, then any character that is not a quotation. So now we don't say any character that is not a comma because the comma is also part of the field data, right? So here we don't say any character not a comma. We say quotation and then any character that is not a quotation as much as possible followed by a quotation. So quotation, and then any character that is not a quotation, including the comma also, obviously. So that match ends here, and then also another quotation at the end. So this entire field is then matched as one field. So we can then match partially quoted CSVs by setting a fpat to be this regex. So this is a extended regex, so we don't have to escape the pipe or the plus symbols. So if I set the fpat instead of fs this way, and then if I, let's say, just print some column. So let's say I print the $3 maybe. And if I run this /script on the Spotify dataset, so you can see we are always getting the third field. So we are never getting name of another artist. Whereas if I set the, instead of fs, if I set the, instead of fpat, if I set the fs to be comma, then you can see it will only work for songs which have only one artist, basically where they don't have a comma inside the field. You can see these are not working correctly. So for partially quoted CSVs, you have to set the fpat this way. If you set both fs and fpat, awk will ignore the fs, it will use the fpat. So this way we can correctly match in both the cases. If it's quoted also, it will match correctly. If it's not quoted also, it will match correctly. So hopefully this makes sense.
So basically, for the second pattern, we are saying it should start with a double quote. Then
Yes.
it should not have any number of characters that is not a double quote,
Yes.
and that should end with a double quote. Is it?
Yes, exactly. Yes. So that is one of the pattern, or another pattern is any character not comma as much as possible. So these are the unquoted fields and these are the quoted fields. So here if I, let's say, print the $2, so you will see that some of them will be quoted and then some are not quoted. So if you want to remove the quotation from the fields that are quoted, how can we do that? What command can I use?
tr.
tr is in bash, yes. So for example, if I want to do it in sed, how will I do it?
Sed, substitute
S.
Yes, S and then quotation with nothing, right? So same thing, so sed substitution we can do in awk using a function called gsub. So sub basically is substitute once, and gsub is like the sed something and then g at the end, right? So global
substitution.
Yeah. So here what I can do is I can ask it to substitute quotation. So this is a regex quotation with nothing. So this is a string. So opening quotation, closing quotation, and anything inside will be a string, but we have not given anything. So this is an empty string. So substitute quotation symbol with nothing on the $2. So then if I run this, you can see even if it was quoted, it is now no longer quoted. So that's why we can. So this is just one application. We can use gsub to do any kind of substitution. So that is totally up to you.
Similarly, we have to remove the commas also, I guess. I guess it's a last name, comma, first name, right?
Yeah, those also if you, let's say, want to do. So for example, if you want to substitute all the commas with, let's say, colons or something, so that is also possible. So here if I do comma and then I substitute that with colon on $2, so then it will basically show you this way. So here if you don't give the argument, if you just give 2 arguments and you don't tell on what string to perform, it will perform on the entire line. So the entire $0 will be affected. So in this case, okay, I don't know why it is not working.
Nothing is given, right? Nothing will be printed, right?
No, this is basically working on $0. So it is substituting.
You give print $0. We are printing $2.
Okay, let's see. Yeah. Okay, it is substituting the everything, every comma with colon in $0. So you can see all the commas have become colon here. So if you don't give the third argument, it is by default assumed to be $0. So let me show that. If I remove this, then also you can see it is working on $0. But in this case, we want to do it only on $2, so we give $2 here.
Sir, where can we get the list of all these functions inside the bash itself?
You can, yes, you can type info awk, and here you will get a book kind of documentation for awk. So here you can see chapters, right? So there should be some chapter on functions. Command line options, other arguments, naming standard environment variables, exit status, loading shared libraries, maybe. Okay, it's not here.
It's in command line itself, I guess.
See, in command line. No, this is
description.
So here you can like basically go through a lot of information will be there. So just like we can set the FS in the begin block, you can also set it while running the awk command by giving a minus capital F. So there are also a lot of variables. One important is this minus V. So if you want to give any variable from bash itself inside awk, you can use minus V and give a variable and its value. So inside that awk script, that variable will then be present and you can use that variable. This is useful when you want to pass a bash variable into awk as a variable. So you do, so let me just show that. So for example, here if I, let's say after this, I print ABC, which is a variable. So it is empty. So it is not printing anything. But if I, okay, I cannot do it this way. If I run it using awk, so awk minus f script.awk. So right now it is empty. There is nothing. But here now, if I give minus v, ABC equals 1, 2, 3. So now you can see it's getting the value 1, 2, 3 automatically. So in this script, we are printing ABC and it is automatically coming as 1, 2, 3. So hard coding a value is not that useful, but what is useful is we can give any bash user variable also, right? So I can give $user and you can see it is automatically getting the value of my $user. So this is one way of passing variables. Another way you can use directly a dictionary called environment without the last 4 letters. So in here, it will automatically have all the variables that is there in the bash environment while this awk was started. So here, if I let's say give environment user, then also we will get the same output. So we had a comma. So then also we will get the same output. So if you cannot change how the awk is called, you can still get all the bash variables from that environment by using the environment dictionary. So just make sure you're quoting the key that you are giving. So if you don't quote this, then this will not work. So then it is assuming that user is a variable whose value you should use as a key. So that is not correct. So this is a string that you are accessing in a dictionary, right? So it's very similar to Python. So then you will get all the environment variables. So here, let's say I set some value like ABC. Again, let me set to 1, 2, 3. And I'm not passing it this way. So I'm not giving it to awk. So ABC does not exist. So here, if I do ABC, so ABC does not exist in awk. So it will not print. But because I have set ABC to 1, 2, 3, it is a bash variable. So here I can do environment of ABC and that will work. So we get 1, 2, 3. So this is a very useful dictionary. So this is automatically created. Let's see what how to see all these functions. We were trying to see that.
So we can sort slash function, right?
Yeah.
Capital F function. It's coming.
Yeah. Okay, it's coming.
Yeah, I searched it. Go to that one. It's
string. Yeah, not string function. So you can go to this chapter, string functions. So it is part of this string functions, string manipulation functions. So here you can see things like a sort, I. There will also be other things, gen sub, e sub, which we saw right now, regex replacement target, index to get index of some string that you're finding, length of a string, match something, etc. So all these also you can go through even during the OPPE. So although you should not have to search it during OPPE because you won't have so much time to read through all this. But if you forget something, how exactly it is done, you can quickly go through it in the OPPE as well. We can also split things. So for example, we have already split each column, but let's say inside each column also I want to split it. So this is a very good example, because here inside each column also we have commas. So let me not substitute the commas and all, and let me just print the $2. Let me remove all this. You can see we have, in some cases, we have this multiple things with commas, right? So what I can do is I can create a, let's say, a temporary array. So I can say split. I forgot the syntax. Let me see that. A string array and then field separator. So I can say the string is obviously $2, and let me create a temporary array. And the field separator is comma. So I'm splitting by comma again inside that field. So then what I can do is, instead of printing $2, I can say for key in the temp array, I print each value one by one. So then you can see each of those are printed one by one. So here we also had a space after comma. That's why we also have like it indented this way. But you get the point. So here, if I think if I put a space also, it should be gone. Yeah. So we are printing each artist on a separate line. And if I want to like differentiate which like is a different record, I can also, let's say, print some lines before it. You can see these are like for each song. This song is only one artist. This song is only one artist. This song is two artists. Right. So we can also use split to split strings inside, like after we have already splitted columns. For each column also, if we want to split a column or we want to split any arbitrary string, we can use the split function to split that and store it in an array, and we split by a field separator. And the split function also will return you how many there are. So if I, let's say n equals, so this you can also print. So I can say, let's say I can put n here. Again, I can put some arrows. So this will tell you exactly how many there are. So you can see for this song there is only one, and similarly for these. But this one there are three, right? So we get these three users. So you can just go through these functions in awk also. They are very useful. So split and match, index, gsub, they are very useful. Length also obviously can be useful to see how many there are. And sprintf also is useful too. So printf directly prints to the screen, whereas we can use sprintf to basically format a string and store it as a string and not print it to the screen. So this is one of the examples.
So in gsub, can we substitute a word?
Can we substitute
a word with another word, or only regex will work?
Yeah, it can be a string also. One second, let me see here. No, I think it has to be regex only. But if you want to basically substitute a word, you can just put word boundary, right? So word boundary and then the word and then again word boundary. That should work.
Okay, thank you.
This is one example. You can see how we can use sprintf. So let's say I'm doing pi equals and then %.2f. So this will basically is a float format specifier, and we are taking only 2 decimal places. And then this is approx. I'm telling pi equals this much approx. And this the number we are giving to this format specifier is 22 by 7. Right, so 22 by 7 will give you 3.142857142857. So if I take only 2 digits, we will get 3.14. Right. So it will not print it to the screen. It will return the string which we can store in this variable. So then we can later use this variable anywhere we want. That is the difference between printf and sprintf. Okay, so there are a lot of such functions in awk also. So just go through the important ones. So mostly we will be using things like gsub, split, match, substring, etc. You can also go through the functions in this page, quick ref awk. Right, so that is pretty much all there is for awk. So you can access associative arrays as we saw by setting value to a key, and you can also see if something is there in an array by doing key in array. So if I do key in array, then it will give 0 if it is not there, and it will give 1 if it is there. So sorry for the disturbance. Just give me a few minutes. Sorry for that. I don't know why there are so many processions just one day before OPP. Yeah, so you can also not match a regex. So I forgot to demonstrate this one. So we saw we can match a regex. Like I can say like $2 is like the regex E. So basically there is a letter E in that like name of the artist. So you can see we are not printing some artist which does not have any letter E in their name. But I can also say do the opposite. So only for those that don't have E, print that. So you can see we only get those artists that don't have E in their name. So similarly, you can do it for any regex. I'm just giving an example. So tilde will match that regex and not tilde will inverse match that regex. So I think that is pretty much there is for awk. Just let me know if we missed over something important.
Sir, for loop we did not explain.
No, we did for loop, right? This is for loop.
Okay, okay.
Yeah, so there are two types of for loops. You can have like Python style iterator for loop. So for iterator in iterable, or you can have C style for loop also, like for I equals 1, I is less than n, I plus plus, print temp array I. So let me comment this out. So both will work the same way. So you can have C style array also, you can have Python style array also. Both are supported in awk. And similarly, we have while loops also, while loops and do while loops. So you can have a while loop with a condition. So very similar to C or Java, C, C++, Java. So while, and then in brackets a condition, and then inside the braces, you can put commands that you want to run as long as this condition is true. So for most cases, the syntax of awk will be similar to C, C++, Java, or similar to Python. So like some things you can see similar to Python, like dictionaries and for iterators, and some things are similar to C++, Java. And you can also, I forgot what I was. Yeah, so you can also use break and continue to break out of loops and continue to the next iteration of the loop. But you don't have break 2, break 3, etc. that you have in Bash. So that is only present in Bash. If you want to, let's say, break a outer loop in a nested loop, then you can only do it in Bash. So in awk, you can do it similar to C, C++, Java. You can write a break that will break the closest loop that is it is inside. Okay, so that is pretty much all there is for awk. So let me just demonstrate a few esoteric things also that are given as an example. So one thing is the fields width. So hopefully this you're familiar with because this was part of one of the PPA GPA. So if you set the fields width to be something, then it does not use the FS or FPAT. It will split each field according to that fields width exact. So if I set fields width to be 343, then it will always take the first 3 characters of the line as the first field, then the next 4 characters of the line as the second field, and the next 3 characters of the line as the third field. So it does not matter if the characters are space, tab, or normal character. It will simply count the number of characters. So that is useful if your file is basically a fixed length kind of file. So some records will be fixed length kind of record. So in that case, you can use field width for that. Okay, so let us also see one esoteric example like this. So let me write this down first. So we have this data.csv, right? So which has 9 rows. Okay, let me do it actually for the letters. It has 26 rows. So what will happen if I do this on the letters file? So what will be the output of this? So what does this mean? So can anyone break this down?
The record separators will be like will calculate which are divisible by 5 and return it as comma, else as semicolon.
Yeah, right. So this is a ternary operator. So also I think I have to put it inside cases. Yeah. So this is a ternary operator. So I'm telling if the line number is a multiple of 5, then set the ORS to be new line. Otherwise, if it's let's say 1, 2, 3, or 4, then set it to be comma. So it will basically
First one will be the true, right? The second one will be false, right?
Yeah, but NR mod 5, if it's 0, in awk 0 means false and 1 means true.
Okay.
Yeah,
Zero
like
means
most
false.
languages.
Okay.
Yeah. Only in bash, like the exit code 1 means or non-zero means error and 0 means success. But in awk and yeah, so that is actually exit code, not like numeric value. But yeah, anyway. So in this, like 0 will be false. So if this is false, then it will be new line, and if it's true, so then it will be comma. So what this will do is it will concatenate 5 lines one after the other, and again in the 6th line it will come on the next line. So let us see. As it's not printing, I forgot to print it only. Okay. Yeah, so you can see because we have 26 lines, right? So 26 will have like 5 groups of 5 and then 1 letter separate. So it's taking for 5 lines, it's concatenating one after the other by keeping commas between them. And then after the 5th line, the ORS, which is the output record separator, that becomes new line. So then it goes into the next line. Again, the next 5 lines are side by side, and then it goes into the next line. Hopefully this makes sense. So you can go through this page. So there are also some other examples like this, which will make it more clear how awk works. So let us end today's session here. So we have taken 3 hours to discuss sed and awk. So I'll stop the recording and then we can discuss some things further.